Hi everyone, am I audible? Yeah. Hi everyone. Hi. Good evening. Yes, I will record. When I start, I will be recording. Yeah, good evening. Walaikum salam. Assalamu alaikum everyone. So yeah, I will be sharing the recording, no worries. Anyways, we'll stay for about 5 to 7 minutes and we'll get started. And those who doesn't know regarding our chemistry seminar, you can just share this with them so they can get the maximum benefit. Osama, I will be discussing what are the lessons we will be talking about. So I know what are the important lessons. So I'll be focusing on important lessons, one in grade 10, another one in grade 11. The major lessons will be covered. Okay, right. We'll wait for some time. Okay, guys, so let's get started and yeah, let's move on. Let me start recording. I hope it started recording, isn't it? Right. Let's get into the lessons. Right. Now, when you talk about chemistry, our whole syllabus, the grade 10 and 11 whole syllabus chemistry, we have 10 lessons. We have 10 lessons. So 5 lessons from grade 10, 5 lessons from our grade 11. So I told you more than the physics, more than the biology. If you focus a bit in chemistry, still you can have a pass. Okay. So the thing what you wanted to do here is you have to focus on the important lessons and do the study schedules. So now when you talk about the structure of matter is very, very important because structure of matter lesson is going to be the head of the chemistry. And then you will get the lesson chemical bonds. So chemical bonds and structure of matter, always you will get the questions together. And then changes of matter is one of the major lessons. This is like, it will take some time for you to study and it will be really complicated because it has a lot of theories and lots of experiments to be done in the changes of matter. So rate of reaction lesson is very, very easy. So since quantification of elements and rate of reaction, if you don't bother about it, if you can focus on these three lessons, also will be very grateful when it comes to grade 10. Then grade 11, mixtures lesson. What are the things you have to study? Homogeneous, heterogeneous mixture, solubility of solute and gas, concentration, physical methods. So you need to study thoroughly in grade 11. The mixtures is going to be the lesson head. Then acid, bases and salts. Those are very simple lessons. You can just study within 10 to 15 minutes those lessons. Then heat changes associated with chemical reactions. Those lessons are going to be very easy. Right then, electrochemistry is going to be the major lesson in your grade 11. That is going to be a big lesson in chemistry. And then hydrocarbons and their derivatives are going to be the very easiest and rarest lesson that comes to your exams, like 2 marks, 1 mark questions only you usually get it. Now out of 10 lessons in your syllabus, how many lessons you have to focus more in chemistry? How many lessons you have to focus more in chemistry? When you look, yes, is it 5 or is it 6? Very good. So we have to focus on 5 lessons. Guys, give me a second. Right. Okay. Am I audible right now? Am I audible right now? Right. Okay. So, guys, so I am here to help you out with the chemistry lesson. So, most of the time, structure of matter, many more times you have studied about structure of matter. And then you have studied about chemical basis of life. So, I would like to give you knowledge on changes of matter because in the changes of matter, you have a lot to learn in that. So, I thought of teaching you the theory of the changes of matter. Are you all okay with that? Then I will go with the electrochemistry. So electrochemistry and changes of matter are going to be the head of your exam paper. Most of the questions comes with that question. So I would like to do with that, right? Because if I start with the periodic table, first ionization, electronegativity, these are very, very easiest questions because you have most of your O level, most of your term papers, you have done enough questions related to the structure of matter and chemical bonds, Lewis structure, ionic covalent bonds, and all of them. So I thought of doing for you the changes of matter and electrochemistry. So I would like to start with the changes in matter and then I will go with the electrochemistry, right? Clear? Chemical bonds are really easy. There's nothing much in the chemical bonds. There's no calculations in the chemical bonds. All you wanted to know about the difference between the ionic and covalent bond and how to draw the Lewis structure for that comes under covalent bond. These are the things you have to learn. But when it comes to changes in matter, chemical changes, reactivity of metals, production of iron, production of gases, then you have a lot of experiments that comes under changes in matter. So why don't you give more importance? Because the rest of the lessons you can study by your own. But when it comes to the changes in matter, it will be really complicated for you to focus, because you need a guidance for that lesson, because sometimes when you read your textbook, you don't understand. Right? Clear? Got the idea? So in the changes in matter only, you have the balancing chemical. Do everyone knows to balance the chemical equation? I know very few of them knows, but very few of them doesn't know regarding that. That means equal amount of students, yes, there will be no. So some people doesn't know how to do the chemical equations, balancing and all of them. So in this lesson only, you will be learning chemical balancing chemical equation, types of what do you say types of calculation comes. So there are so many things about moles, calculating moles, number of moles, grams. So lots of things will be coming under this lesson. So I thought of doing this, and most of them will be refused to do this because this lesson is the hugest lesson in chemistry in grade 10. So shall we get started? And then we'll go to the electrochemistry. Some people asking me mixtures. Mixtures, every first term paper, second term paper, third term paper, you will be learning about mixtures. Most probably mixtures comes with kind of a physical method. Like you have to learn about solvent extraction, salt production, these things. And then always they will come up with the question with concentration. Fraction questions, concentration questions, every time you get it. But that is not the main. Electrochemistry going to be the main. And then with the you should know the polyatomic ions, 6 polyatomic ions, and then you have to know what changes of matter. So shall we get started into the changes of matter, because we have a lot to cover and we will be finishing it off, right? So during that lesson itself, I will be teaching you how a question might come and how you have to face it, right? Okay, so let's get started. Are you all ready? Right. So is the board is visible? Right. I'm not using too much light, because if it is too much brightness, sometimes it won't be uh, clear, it will be blurry. Okay. Right. We'll get started. Okay, right. Now listen. Now, today we are going to study the most complicated lesson in chemistry, where everyone says this is the one of the complicated lesson, and it is really hard to finish. Now, remember, now the thing that you are studying with me, right? So when you are studying this lesson, think one part of your chemistry lesson is over. So you are not going to touch the same lesson again and again and waste your time. So that is how you have to think, and that is how you have to work. Are you ready? Okay. Right. Listen, whenever I ask questions, you all have to reply. So that is the way that you can boost me and motivate me to do well. Right? Okay. So, right. Let's get started. So, today we are going to study about changes in matter as well as the electrochemistry. So, when you talk about changes in matter, so this is one of the important lesson in your chemistry, where every time in your O-level paper, there will be a compulsory question in changes in matter. Right. Listen. Now, first of all, we need to know what is a matter. So, when we talk about matter, what do you mean by matter? Think, what do you mean by matter? So, when we was grade 6, we know matter means what? Matter means what? It has a mass as well as it will occupy space. So, a substance that has a mass as well as that will occupy space, that we call it as what? Matter. changes in matter. So what is our heading? Our heading is about changes in matter. So we are going to study about the substance which has a mass and occupies space has changes. So what are the changes are we going to study? We are going to study about two changes. So what are the changes are we going to study? I can't zoom because since we are using the camera cannot be zoomed out. If it is a screen, can be zoomed. Right. Okay. So now when you talk about changes in matter, there are two changes in matter. One we know that is physical change, as well as other one we call it as what? Chemical change. One we call it as physical change, other one we call it as chemical change. Now first let's talk about the physical change. Sometimes they can even ask you about physical change. Now even though physical change they do not ask in all the exams, what if they ask in our this time paper? So we have to be aware about it. No, so let's talk about the physical change. So when you talk about physical change, when you take the substance, what are the three mediums that comes under matter? What are the three states of matter that we know? What are the three states of matter? Very good. We have solid, we have liquid, and then we have gas. So we have three states of matter: solid, liquid, gas. So when you talk about this solid, liquid, gas, how are they packed and how are they arranged? So when you talk about solid, they are tightly packed. When you talk about liquid, liquid is they are loosely packed. When you talk about gas, gas is what? Freely packed. So now we know that these people in this way, because in grade 8 also we studied how this solid, liquid, gas and everything is packed. So now you have the ice. Think about ice. Now ice is made up of what? Now if I talk about ice, it is made up of what? Now we know ice is made up of water. By freezing the water, we made the ice. So ice is made by freezing the water. So by freezing the water, we have made the ice. So when you keep the ice in the room temperature, everyone tell me what will be the room temperature? The room temperature is 25 degrees Celsius to 30 degrees Celsius. So this is our room temperature. Okay. So when you keep this ice in the room temperature, what will it become? What will this ice will become? We saw that the ice is turning into what? Liquid, which is we call it as water. The ice is turning into liquid, which is called as water. Now both of them are water. Now ice in solid state water, water in liquid state water. So now it has changed when it is converted from solid to the liquid. What is the difference between them? Has the substance changed when it convert? Like, now think about, has the substance has been changed? Look here. Now look at the ice. Ice also is a form of water. Ice also is a form of water. Liquid state of ice also a form of water. My question is, has the substance has changed? Like say water has changed to log. Water has changed to ashes. Did it change like that? No, it has not changed. That means the only change that you can see from the ice to the liquid is that has converted from solid to liquid. So the complete substance has not been changed. That means we can understand in the physical change, the only change you will be saying is what? Arrangement of particles will be changing. What is that? Arrangement of particles can be changed in the physical change. Now say for example, I have liquid in my hand. Now say for example, if I heat the liquid, now say I have a cup of water, I am heating this cup of water until it becomes 100 degrees Celsius. What will this water will become? The liquid water. What will happen to this liquid water? This liquid water, once it to gas, that means the gas is going to be the what? Now initially you had the water in the form of liquid. Now once it turns into gases, the water is turning into the form of what? It is forming into the form of gas. So that means water, gas, water, liquid. Did the water change to something else? In this case, no. So the medium has not changed. The only thing that you can see is arrangement of particle has been changed. So this type of change We call it as what? Physical change. Clear with that? Clear with that? So by heating my liquid water and turning into the gas water, did I form any new substance? Did I form any new substance? Did I form any new substance? No, I didn't form any new substance. So that means when you convert the water, now say for example, water liquid has been converted into water gas. Did the water change? I mean, did the water change into something else? That is what I'm talking about. No, the arrangement of particle has been changed. Initially it was liquid, now it has changed into the gas. Only the arrangement of particle has been changed. This kind of change, we call it as what? We call this as physical change. Now, did you understand what is a physical change? Clear with that? Got the idea? Now, say for example, now you have the ice. Okay? Say you have now what is happening if I heat the ice? Now, if I heat the ice, what will happen to this ice? Ice will turn into water. Ice will turn into water. If I heat the water, water will turn into the gas. So now you know these names. Converting the ice into the water. What is that name? Conversion of solid substance into the liquid substance by giving a boiling point. What do we call that as? Very good. We call that as melting, or in another term, we call that as fusion. We call that as what? Fusion. Converting water into the gas, we call it as what? Vaporization, or we can call that as evaporation. Evaporation. Now the reverse. Gas is being converted into water. We call that as what? Condensation. We call that as what? Condensation. Converting water to the ice, we call it as what? Freezing. We call this as what? Freezing. Directly converting a solid to the gas, we call that as what? Sublimation. We call that as what? Sublimation. Converting a gas back to the solid again, also we call it as what? Desublimation. Right? Clear with that? Understood? Okay. Now, let me ask you a question. Now, some people say, okay, they didn't understand and everything. Now, just listen to me and you answer and say. Now, let's say you have a stone, crystal stone. Okay, you have a stone in your hand. If you break it and if you make the powder, so what is the change you can see? Is it a physical change in the stone, or is it a chemical change in the stone? You take a stone, you break the stone, and you see the stone still. And is that a physical change or is that a chemical change? It is a physical change. Whenever in exam, if they say something like melting, or whenever they say the word like fusion of ice, melting of ice, what kind of change is that? Physical or chemical change? Physical or chemical change? It is a physical change. And again in exam, if they say melting of gold, freezing of gold, if they say vaporization of gold, again you need to understand it is a physical change. So if they use any word, those like freezing, sublimation, melting, tearing, breaking, vaporization, evaporation, condensation, these things comes under physical change. Clear? Understood? Got the idea? Understood? Right. Now we have to study about chemical change, which is very important for your exam. So physical change is over. Now we have to go with what? Chemical change. Now let's talk about chemical change. So when you are talking about chemical change, listen to me very carefully. Listen to me very carefully when you are talking about chemical change. Sometimes when I write small handwriting, some people can't see. Okay, I mean those who are using the YouTube or that, sometimes it won't be visible. So let me write a bit bigger. Okay. So let's talk about chemical change. Now, let me ask you a question. Say, for example, you have a piece of wood. Say, for example, you have a piece of wood. Okay. Now, you burn this wood. Now, once you burn this wood, what will it turn into? This wood will turn into what? If you have a wood, you burn the wood, this will become what? Ash. This will become ash. Can you convert the ash back into the wood? Can you convert the ash back into the wood? No. So wood is a substance and ash is another substance. So wood and the ash, is that same? No. So wood is a existing substance while the ash is a new substance. So always remember, burning something in the presence of air, we call that as combustion. We call that as what? Combustion. So now what did I do? I did combustion to the wood, and the wood has been turned into ash. So now it's producing ash too, which is totally a new substance. So is this a physical change or is this a chemical change? This is going to be a chemical change. So you need to understand, chemical change means where existing substance undergo change to form a new substance, that you call it as what? Chemical change. Clear with that? Clear with that? Okay, let me test your brain. Now when I test your brain, now say for example, I have candle. I have candle. Now when you heat the candle, now what is happening to the candle? What is happening to the candle? The candle is becoming, it will melt and it will become what? It will become wax. It will turn into wax, right? Okay. Now, melting. What kind of a change is that? Now, I use the word called melting. So, whenever I use the word melting, is that the physical change or a chemical change? It is a physical change. Now, did you understand? Since some people say candle is different, wax is different. No. Once you melt the candle, you will get the wax. Once you freeze the wax again, you will form the candle. So, it's like a reversible process, right? Did you understand? Now, say for example, now what is happening is, now when I burn the candle, combustion means if you are burning anything in the presence of oxygen, we call that as combustion. Now, say for example, you have a candle. Okay, now the same candle only. Now, when you burn the candle, now what is happening is, now when you're burning, have you seen some gases are going out from the candle? We call that as wax vapor. We call that as what? Wax vapor. That wax vapor is considered as a hydrocarbon. It is a hydrocarbon. Now this hydrocarbon, hydro means hydrogen, carbon means carbon. So that means, now I told you, when I burn something, what is happening? Whenever I say the word burning, what do you understand? I am performing combustion. So combustion means what? You are burning anything in the presence of oxygen, we call it as combustion. That means, now wax vapor is a hydrocarbon, no? So wax vapor contains hydrogen and carbon. This hydrogen and carbon will react with oxygen and it will form a new substance. So that what kind of a change is taking place in the candle while you burn the candle? That is a chemical change. So that means oxygen will react with hydrogen to become water vapor, while oxygen and carbon will react together to form carbon dioxide. So that means the new substance has been formed by the wax vapor by doing the combustion. So that means two activities are taking place. When I burn candle, candle is being melted and becoming wax. That is physical change. While that is happening, wax vapor also being released to the environment. Therefore, it is reacting with the oxygen to produce water as well as to carbon dioxide. Clear? Clear? So now in exam, if they say anytime if they use the word new substance form, what should be your answer? Whenever they say the word new substance has been formed, what can you understand? So new substance means it should be a chemical change. Clear with that? So new substance means it is a chemical change. Whenever they say the word melting, freezing, fusion, all of them comes under physical change. Clear with that? Understood that? The candle incident was an example that I used because in one activity, two changes can take place. One change can be physical, other change can be chemical. So in one, there can be two changes taking place. Since I told you candle will be melted and becoming a wax, that is a physical change. At the same time, candle will be evaporating some wax vapor, which we call it as the hydrocarbon. That means this wax vapor is made up of hydrogen and carbon. So this hydrogen and carbon will react with the oxygen that is present in the environment. So when hydrogen react with oxygen, they become water. When carbon react with oxygen, they become carbon dioxide. Clear? Understood? Got the idea? Yes? Right. So now chemical changes also done. Chemical changes also done. Right. Chemical change means the change that is taken by, now we can say a change that is taken by the existing substance to produce a new substance. We call that as what? Chemical change. Hydrocarbon means it's a substance that contain hydrogen and carbon. Okay. Right. Now let's talk about chemical change. Let's talk about chemical, sorry, not chemical change. We have to talk about chemical reaction. We have to talk about what? Chemical reaction. Now, same example I'm going to ask you and you are going to answer me. Now, you burn the wood, right? You burn the wood. And once you burn the wood, you got ashes. You got ashes. So, which is the substance that undergone the change? Who changed? Wood changed into ash or ash changed into wood? Who changed? Who undergone change? Wood has undergone change. So, the substance who is about to change, we call that person as reactants. Reactants. We call them as what? Reactants. So, whenever we talk about chemical reaction, in a chemical reaction, there will be a person called reactants who is going to change. Now, once they change, a new person will be formed from the reactants. No, that person, we call them as products. We call that as what? Products. So, products means what? The new substance that is formed by a change, we call that as products. The existing person who is going to, now when you talk about reactants, who is reactants? The substance that is undergone change. Substance. Sometimes when I talk, I can't write because it's a kind of problem. Substance that is undergone or undergoing, we can write undergoing change. Undergoing change, we call that as reactants. So that means always from the reactants, only new products are produced. So products means what? So substance that is formed during reaction, we call that as products. So that means from wood, ashes are produced. Like what? From the reactants, the products are produced. Clear? Understood that? Got the idea? Right. Now listen. So now we need to study about chemical reaction. We need to study about what? Chemical reaction. What are the types of chemical reaction? We need to study different types of chemical reaction. Now listen to me carefully because this is the very, very important part. MCQs, most of the MCQs, most of the structured paper, you get this. Listen. The first type of chemical reaction that you are going to study is chemical. Give me a second. Sorry, I was about to cough. Right. Right. So the first type of chemical reaction, we was calling it as what? Chemical combination reaction. Chemical combination reaction. So what is the first type of chemical reaction? Chemical combination reaction. Okay. So now, when you are doing this lesson, first thing, you should know the periodic table. You should know the periodic table. Not only periodic table, you should know the 6 polyatomic ion. You have to know what? 6 polyatomic ion. And not only that, you have to know the periodic table with the valency. Now let me give you an idea regarding that. So now we know the periodic table. No? So it starts with hydrogen, then helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Now, when you take the periodic table, always remember you should know there's a shortcut to remember the valency. So valency means what? What do you mean by valency? Valency will be helping you to do the chemical formulas. So what is happening? Always start from +1. So the valency for the group 1 is +1. Then +2, +3. Then when it comes to fourth group, +4O -4 -4. So you have to go with the reverse. -3, -2, -1, 0. So that means the group 8 will be considered as the noble gas. They will not have any valency since that they are considered as 0. Then when you come to this +4, next to the +4, you have the group 5. No. So you have the +5, +6 and +7. So these are the valency that will help you to do the chemical combination reaction. So this is how whenever you go to the exam, try to write the periodic table before you forget, and then you can mark all the valency. Then you should know the 6 polyatomic ion. So hydroxide, so OH minus, then ammonium NH4 plus, NH4 plus. That means what can be the valency of hydroxide? If it is just a symbol, remember it's going to be -1. If it is just a symbol with plus, it's going to be +1. Then you have to remember what? Carbonate, CO 2 minus. So CO2 minus, you have to remember not carbonate, carbonate, CO3 2 minus. So CO2, CO3 2 minus. You should know the carbonate. Then phosphate, PO4 3. So 3 minus. You should have the PO4 3 minus. Then phosphate. Then you should know nitrate, NO3 minus. Then one more person is there, sulfate, SO4 2 minus. So these are the polyatomic ions that you have to remember. So what is the carbonate? Carbonate, what is the valency? -2. The upper person will come as a valency of all the polyatomic ions. So when you are doing the lesson chemical combination reaction, you should know the periodic table with the valency, and you should know the 6 polyatomic ions with the valency. Clear? Understood? Got the idea? So shall we study what is chemical combination reaction? Shall we study what is chemical combination reaction? Okay, now listen. So now when you talk about the chemical combination reaction, now say carbon is going to polyatomic ions means atoms with several charges. Atoms with several charges. That means polyatomic ions. So poly means several atoms. Several atoms with charges, we call it as what? Polyatomic ion. So that means you will have several atoms. Those atoms will have charges. We call that as what? Polyatomic ions. So polyatomic ions are very important when you do the chemistry, right? Okay, now listen. So when you talk about chemical combination reaction, we are going to do the simple combination reaction. Say for example, carbon is going to react with oxygen. Carbon is going to react with oxygen. Now, do you have oxygen 1 in the nature? That means oxygen atom in the nature, or do you have O2 in the nature? What can you say? You have O1 in the nature or O2 in the nature? You have O2. So let me write it as O2 over here. Now tell me, what is the valency of carbon dioxide? What is the valency of the carbon dioxide? Always remember, whenever I am doing a chemical reaction, chemical combination formula, remember the starting person has to have the positive valency. It should have the positive valency. Now tell me, the next person should have the negative valency. First person has to be positive, other person has to be negative. Now oxygen, when you talk about oxygen, what is the valency of oxygen? -2. So now when you get these charges, just forget about the charges. When you apply it, remember the charges. After you write, forget about the charges. After you forget the charges, you can see that 4 and 2 are like multiples where you can simplify. So can you simplify this 4 and 2? Yes, 2 times 4 is 2. So now this 2
will be given to the side of oxygen, and this one will be given to the carbon. It will be given to the carbon. So therefore, carbon 1, should I mention this one? When it comes to chemical combination reaction, should I mention this one? I don't need to mention this one. So without mentioning this one, I can write CO2. So combination of carbon and oxygen, you are forming carbon dioxide. Now my question is, do you want to by heart? Do you want to by heart this kind of combination reaction? Do you want to by heart? No need. But there are some you have to by heart. Now there are things that you have to by heart. Now some things you can show the working. Now see, carbon and oxygen combining together, you showed the workings. But there is a reaction. There are some reactions you cannot show. You cannot show by working, but directly you should have memorized. Say for example, now say for example, carbon dioxide is there. No? Carbon dioxide is reacting with carbon. Now, carbon dioxide reacting with carbon, can I find any valency for the carbon dioxide? Can I find any valency for the carbon dioxide? No. But can I find the valency for the carbon? Yes, but still, since you don't have the valency for the carbon dioxide, you have to memorize when a carbon dioxide and carbon combine together, they will be forming carbon monoxide. They will be forming what? Carbon monoxide. So this one you can't show to the people. And also you have to memorize. However, you have to remember the formation. Clear with that? Understood that there are two things. One thing you don't want to memorize. Other one, you have to memorize some combinational reaction. So one combination reaction is what? Carbon and oxygen. This is also an element. This is also an element. When two individual elements are combining together, you can show the workings, and you can even take the valency without by hearting. You can form the chemical formula. But there are some things, you have the compounds, you have the elements. When compounds and elements combine together, sometimes you can't find the valency. But you have to by heart that when a carbon dioxide and carbon combine together, they will form carbon monoxide. Clear? Got the idea? I'm showing you both ways. There are ways you don't want to by heart. There are things you have to remember. Got the idea? Understood? Got the idea? Got the idea, right? Right. I will show you another one by using the polyatomic ions. I'll show you another one by using the polyatomic ions. Say for example, now look here. You have the calcium oxide. You have the calcium oxide is going to react with water. Calcium oxide is going to react with water. Okay. Now when you talk about calcium oxide is going to react with water, how to remember polyatomic ions means that one you have to memorize, because there is no way. There are ways to remember, but the thing is like I would better tell you to remember in a normal way. Not like a song, not like a way, but just if you remember, it's better. Okay. Right. Now this is also the compound. This is also the compound. In this compound, you have to find the positive and the negative, positive and the negative. So you can see. Now look here. Now say for example, you have what in calcium oxide. In the calcium oxide, what are the ions are there in calcium? Calcium 2 plus. Oxygen, what is the valency? Oxygen minus 2. Again, I can substitute here hydrogen. What can be the valency? H plus ion. Oxygen, you can now, since water is there, I can't take it as oxygen. I have to take it as a hydroxide. Remember, water is made up of hydrogen plus hydroxide combined together. Only water has been formed. So since that, you can't take oxygen as individually, right? So now what is happening? From this side, you have opposite. From this side, you have positive. Here you have negative, positive, negative. Now, since both of them are compounds who are opposite to each other, calcium will get attracted to the hydroxide because one person is positive, other person is negative. And oxygen, hydrogen and oxygen will combine together. Now listen to me very carefully. Now calcium and hydroxide combine together. They will be forming what? Think and say me. If I combine calcium, what is the valency? +2. What is the valency of the hydroxide? +1. So what happens is, yeah, we can combine. So what is happening is, now imagine, combining this 1 and 2, you are forming calcium hydroxide. Can I put these two like this? Is that the way correct? If I put the two like this, is it correct? No, it is wrong. Why? These two will be only belonging to the hydrogen. So since it is a hydroxide, I have to put a bracket. So calcium hydroxide, I have to put a bracket. That shows, the bracket shows that 2 belongs to hydrogen and oxygen. Clear with that? Now look here. Hydrogen and oxygen combined together, they will be forming water. Again, they will be forming water. Got it? Remember, water will be used in chemical reaction, but every time we don't mention the water. Clear with that? Got the idea? Got the idea? Understood? Now, shall I talk about the chemical reaction? Chemical combination reaction. What did we learn? Under chemical combination reaction, what are the methods they can ask you? Elements and elements. We learned elements and elements. Formula. Sometimes if you mention the formula, you can get marks. Elements and elements. This is an element. This is an element. Element and element combined together, you formed a compound. You formed a compound. This is how we viewed it. First example. Second example, what is that? Compound plus element. Compound plus element. Compound plus element, you form again a compound. Again, you formed a compound. Then again, I'll mark here. Compound plus element, you formed a compound again. Again, what is the third rule? Under chemical combination reaction, they will undergo with 3 rules. One rule is elements and elements combined together and forming a new formula. That is also coming under chemical combination reaction. If a compound and element combine together, also chemical combination reaction. If a compound and compound, calcium oxide plus water combined together, what did you form? Calcium hydroxide. You form the calcium hydroxide. So this is also a compound and a compound. So what do you mean by chemical combination reaction? If elements combines with another element with a compound, or a compound combines with another compound to form a new compound, we call that as chemical combination reaction. You don't need to by heart this definition. So just tell me what can be the definition. Simply say, if the element combines with another element, and element combines with a compound, or a compound combined with another compound to form a new substance or new compound, we call that as chemical combination reaction. So this is the chemical combination reaction. Clear? Understood? Got the idea? Let's go to the second reaction. Let's go to the second reaction. Yes. Right. Now let's go to the second reaction. The second reaction, we call it as single displacement reaction. Single displacement reaction. Okay. So single displacement reaction is the second reaction that you are going to study. Let me tell you an example. Now say for example, now imagine, okay. Now there is a couple already. There is a calcium can get +2 because calcium is the second group. Calcium belongs to the second group of periodic table. The second group of periodic table has the valency of +2. That's what calcium is getting +2. Okay, right. I'm losing my voice, right? Anyway, listen. Give me a second. I'll get some water.
Which outcome dark demon? Right. Okay, we'll see what is the question you asked. But if the isotope instead of actual element, we usually don't use isotopes. Isotopes are very simple part that is there. Like they will only ask you the three types of isotopes: deuterium, protium, tritium. These names only they will be asking in your exams. Okay. The isotope parts you will be learning in detail in your A levels. So still now in your O levels you don't have much anything about isotope. Just a small part is introduction is given, right? So you don't want to worry about it. So now let's talk about the single displacement reaction. Listen to me. What kind of a story is that? Right. Now listen to me. Now say for example, you have a couple. Now imagine there is already a couple. There is already a couple. Okay. Now say for example, this is the boy and let's say this is the girl. So now what is happening is now a new class. Now new girl is coming to the class. Now say for example, a new girl comes to your class. Imagine there's a couple. In this couple, there is a new girl coming to the class. Okay. Now what is happening is the girl here likes this boy. The girl here likes this boy. So what she will do? She will replace the already girl here and she will come to this position. Isn't it? So now what will happen? What did she do? Initially, there was a couple and one girl came. Now imagine. Now say for example. Now say for example, you had a couple and there was a new person coming to break this couple. Now what is happening is initially there is a girl, new girl came and she liked this boy. What did she do is she replaced the already existing girl and she came to the position of this girl. So now what did you understand is, now how many person displaced here? How many person displaced? How many people has been displaced over in this? How many people displaced? How many people replaced here? Replaced. How many person replaced? Only one person. Only one person has been replaced. How many person replaced? Now think. Now say initially you have two markers. Here you have a blue marker and black marker. You have a blue and a black. And then I bought a new black marker. I took this black marker and threw, and I put this new marker. So how many people has been displaced or how many people has been replaced? That is only one. So that is what they say the word single displacement reaction. Did you understand? That is what they say it as one single displacement reaction. Now listen to me. Let's come to the chemistry part. When it comes to chemistry part, say you have magnesium and you have hydrochloric acid. So when you have magnesium and hydrochloric acid is reacting, say this hydrochloric acid is a compound. No? So if this is a compound, imagine if this is a compound, imagine what is happening is this is a couple, then there are two people. What are the ions are present in the hydrochloric acid? H plus ion and Cl minus ion. Now since we know what is the valency of the magnesium, Mg2 plus. Now plus and plus will get attracted or plus and minus will get attracted. Plus and minus will get attracted, which means the magnesium will get attracted to the chlorine. So therefore, what will happen? What is the new couple? Who is the new couple? Magnesium chloride will be the new couple, while the already existing person will be displaced as a hydrogen gas. Clear with that? Got the idea? So when forming products, who took the place of hydrogen? Magnesium took the place of hydrogen. Hydrogen has gone to the other side. Clear with that? Now some people are asking, how did I get the 2 for the chlorine? So how did I get the 2? Now magnesium, what is the valency? Valency is plus 2. For chlorine, minus no. That means what will be the valency for the chlorine? Minus 1. So 1 is getting exchanged with 2. So 2 will go to the chlorine, 1 will go to the magnesium. So therefore we will write magnesium chloride. Clear? Understood? Got the idea? So that is, we call it as single displacement reaction. Clear? Understood? So now imagine when I said hydrochloric acid. So hydrochloric acid means what? When you talk about hydrochloric acid, yes? Right. Now, okay, listen. I'll explain you back again.
I'll explain. Listen. Now, when you talk about single displacement reaction, so when you talk about single displacement reaction, you have, now imagine there is a couple. Okay, there is a couple. So if there is a couple means, just to make you to understand, there is a couple. Okay, let's say the boy is positive, the girl is negative. Imagine like that. And then they are a couple. No? So think that is as a compound. Think that is as a compound. Now what is happening is, now there is a new person coming to their classroom. Now in the classroom there is a couple and the new girl is coming to the classroom. Now let's say the girl is here negative. The girl is here is negative. Now in this case we don't need to use any activity series. After this only we have to learn about activity series. Right? Now listen. So now what is happening is, there is a new girl coming to the class. What she is doing is, she is coming to the position of the already existing girl. So what is it happening? So this person already was as a couple will be removed and will be gone to the other side. So the person who came newly will come as a new couple. So therefore, plus and minus will come as a new couple, while the already existing minus will be like this. Clear? Understood? The same thing happened between the magnesium and hydrochloric acid. So when you talk about magnesium, magnesium, what is the valency? 2 plus. Hydrochloric acid, hydrochloric acid is a compound. It is like a couple. What are the valencies are present in hydrochloric acid? H plus ion and Cl minus ion. So now since we know this magnesium is a positive and positive will get attracted, or positive and negative will get attracted, positive and negative. So that means magnesium will get attracted to the hydrogen, or will it get attracted to the chlorine? It will get attracted to the chlorine. So once it is getting attracted to the chlorine, they will be forming a new couple. How? Magnesium is plus 2, chlorine is minus 1. 2 is gone to the chlorine, 1 is gone to the magnesium. So do we need to mention that 1 to the magnesium? We don't need. Only the 2 will be mentioned at the end of the chemical formula. And who is alone? Hydrogen. So we know hydrogen is alone. Therefore, hydrogen cannot be found as H1 in the nature. We find the hydrogen as a molecule. We find the hydrogen as a diatomic gas. So therefore, you will be finding as H2 gas in the nature. Got it? Understood? Right. Since it's azan, I will take first 5 minutes and I'll be back. Okay. If we mention one is wrong, if you mention one, it won't be wrong, but better if we can ignore. It's not always last one is negative, but most of the time, all the chemical formula will be negative. The last person will be the negative. The first person will be always positive. It's like a rule.
If it is over, just let me know. We can continue. Okay, right. So the single displacement reaction is over. So some people are asking me that how to remember the valency. I told you an easiest way to remember the valency. You have to draw the periodic table, and then you have to just mark 1 plus 1 plus 1 plus 1 plus 2 plus 3 and plus 4. I'm going to go with minus 4, minus 3, minus 2, minus 1. So that's the only way you can remember the valency. That is the only way you can remember, right? Right. Now let's talk about the double displacement reaction. So now let's talk about double displacement reaction. So now when you talk about double displacement reaction, imagine like this. Say there are two couples. Now if I say there are two couples means how many people together? If I say two couples, how many people together? Four people together. So let's say for example, there is a couple here. Let's say this is boy 1 and this is girl 2, girl 1, boy 1 and girl 1 as a one group. And then there is another couple, boy 2 and girl 2, let's name like that. Okay, now what is happening here is, just as an example, say for example, now other girl likes the other boy, so the other boy likes the other girl. So now what they will do, the rules for the single displacement is, always remember the person who is alone will be always get attracted to the negative person. That is the only rule. Okay, so now when you talk about the double displacement, right? So when you talk about the double displacement reaction, it is like cheating. Now say for example, this girl likes this boy and this boy like this girl. Now what they will do, now even they know they are couples, this boy likes this girl, this boy also like this girl, they will say shall we exchange. So what are they going to do is, they will exchange the couples. Now once they exchange, what will happen, this boy and this girl will combine together as a new couple. B1 and G2 will come as a new couple, while the B2 boy will come as a new couple with the G1 girl. Did you understand? Now just tell me, how many people have displaced? How many people has been changed? Don't say 4. Answer is going to be 2. Very good. How many people displaced? 2 people displaced. So let's study in science how it comes in example. Right. Now listen. Now I explained you in a live way. Now let's talk about in a scientific way about double displacement reaction. Now say for example, you have sodium hydroxide plus you have hydrochloric acid. Sodium hydroxide. Now imagine sodium is 1%. Hydroxide is 1%. Hydrogen is 1%. Chlorine is 1%. So sodium, what can be the, now think about sodium. What can be the valency of sodium? Sodium is belongs to group 1. So that means the valency of sodium is +1. What can be the valency of hydroxide? Hydroxide is a polyatomic ion. So since we know hydroxide is going to be -1. Hydrochloric acid, hydrogen is again +1 and chlorine is again going to be -1. Now tell me, if one person is positive here, positive will get attracted to the negative, no? So sodium will get attracted to the chlorine, while hydroxide and hydrogen will get attracted to each other. So therefore, what is the new couple? You will be forming sodium chloride plus hydroxide plus hydrogen. You will be forming water. Clear with that? Clear with that? So now this is going to be the new couple, which means this is the double displacement
reaction. Got the idea? Got the idea? So whenever you see a equation like that, this is going to be the double displacement reaction. Right. Now let's go to the last chemical reaction. That is, we call it as chemical decomposition reaction. That is what is that? Chemical decomposition reaction. They will be showing you an example and they will ask you whether this is a chemical decomposition reaction or whether they will ask you single displacement reaction. So you, by looking at the example, you can see. Now let me ask you a question here. Now quickly say me. Now say for example, let's say for example you have zinc and the sodium chloride. Okay, imagine like that. They have shown you an example like that. And then they have asked you sodium hydroxide is going to react with hydrochloric acid. Okay, now in MCQ, imagine they have given a question in MCQ like this. Okay, so and then they have showed you example also in this zinc, Cl, and they have shown you then sodium is alone like this. And then here they have shown you that sodium chloride together with hydroxide water. Now tell me, in MCQ they have given you. So this is MCQ 1 and this is question number 2. In MCQ 1, if they have given you options like this is a single displacement reaction, double displacement reaction, and if they have given you chemical decomposition reaction and chemical combination reaction. Now which option will be your answer for the first question? What kind of reaction can you see here? What kind of reaction can you see here? Single displacement reaction. This is how they will ask in exam. Okay. Next one. When you look at this one, what kind of reaction is that? The second one. Second is the double displacement reaction. Now, since one person asked me how they will ask in exam, this is how they will be asking. And they will not tell you to like draw and write and show. Like you have to just, usually it comes in the MCQs, right? Now let's go to the double displacement. Sorry, we have to go to the chemical decomposition reaction. So chemical decomposition reaction, you have to memorize. You have to memorize this one. However, you have to memorize because chemical decomposition reaction has no formulas. That means without formulas, you need to know that. Now say for example, you have hydrogen peroxide. Say you have hydrogen peroxide. So decomposition means what? You are heating. You are heating. So what happens is they will show you a symbol like this, says that is being decomposed. So that is getting heated. So now what is happening? You have hydrogen peroxide. Hydrogen peroxide will get decomposed and forming how many products? It will be forming a 2 new product. That product will be, one will be a compound, other one will be a element. Other one will be a element. So compound. Now initially how many reactant do you have here? Always in the chemical decomposition reaction, you have to remember there will be only one reactant and there will be so many products. That is the best way of identifying. So whenever you talk about chemical decomposition reaction, in the chemical decomposition reaction, you need to understand they will be having only one reactant. That one reactant will produce lots of products. It can be more than 1 or 2 products, right? So here you will get it as one as an element and other one you will have it as a compound. This one you have to memorize. Then let's say for example, the second example, potassium permanganate. So potassium permanganate, what is happening? This is one reactant, potassium permanganate. If you decompose, what will it happen? It will form potassium manganate. It will form what? Potassium manganate. K2MnO4 plus MnO2. Again, you will have oxygen. Right. So now what is happening? You will be having what? Potassium permanganate. If you decompose, you will be having what? Potassium manganate with manganese dioxide. Clear? This one you have to know. This one, however, you should know. Clear? This one you have to memorize. Right? Clear with that? To explain this one, what you need to understand is, in chemical decomposition reaction, you can't have like, you don't have a formula like you did for the carbon plus oxygen. Carbon plus carbon is going to be +4, oxygen is -2. You cut off and you took it as a carbon dioxide. No, in this way, that means you don't need to memorize because already you know how the formula will come. But chemical decomposition reaction is not like that. So what you have to do is, they have to, like, one reactant will be there. The only example I can tell you is chemical decomposition reactions, when they give you only one person at the left hand side and lots of people on the other side. Remember, it's chemical decomposition reaction. Clear? And you have to remember these people. You have to remember these people in case if they ask you to write or fill in the blanks, or in MCQ they have asked you which will be the suitable person to come to the other side. So you need to think well and you have to do, because there is no way, right? Okay, listen. Chemical decomposition reaction is there, right? In this chemical decomposition reaction, you will have one reactant on the left side and you will have several products on the right hand side. That is one symptom to find whether they are chemical decomposition reaction or not. And other one is, in chemical decomposition reaction, you don't want to have a formula. Without having a formula, you have to memorize these chemical reactions. So the main thing under this chemical decomposition reaction is, you have to remember at least 2 chemical reactions, just to make sure that you will be safe in your exams. Clear? But very rarely they ask these questions. Most of the time, single displacement or double displacement or chemical combination reaction only they will mostly test it. Clear, right? Understood, right, Shakib? Got the idea? Most of the time, what you have to understand is, usually water is made up of hydrogen plus hydroxide. Hydrogen plus hydroxide. Okay. Water is made up of hydrogen plus hydroxide. But there are situations, if oxygen and hydrogen combine together also, they will be forming water. That is called science. That is how it will be moving on. Do you understand? So if hydrogen, now when you take water, if they ask you what are the elements are present in the water, you have to say hydrogen and oxygen elements. But what are the ions? If they say what are the ions are present only, I have to take H plus ion and OH minus ion. Clear? So whenever I talk about ion, whenever you are doing a chemical formula, then only we have to take like this. But initially, if you say if hydrogen plus oxygen combine together, yes, they will be forming water. There are 2 ways that will do. Okay? Right. Okay. Now listen. How to remember these compound names? You don't need to remember the compound names because they do not ask. But if you can, like when they say sodium, chlorine, sodium and chlorine together, sodium chloride, like that. You have to remember. If they say copper and they have given the word sulfate, copper sulfate. That's how you remember the compound. Okay. Right. Now let's come to the activity series. Now this is very important. We have to come to the reactivity series. Reactivity series. How many of you all know activity series? How many of you all know activity series? Okay, I will teach you a way to learn. Those who haven't learned, those who don't know the activity series, I'll teach you a easiest way to remember the activity series. Okay. So before that, we need to know what is activity series. So activity series means they have taken elements in periodic table and arranged them according to their reactivity. That means how much fast are they reacting. According to the how much fast are they reacting only, we have taken the reactivity series. Now say for example, now say in the first, I will be teaching about the balancing equation, okay, after the reactivity series only. Okay. Now listen. So when you talk about these elements, when you talk about these elements in periodic table, and what you have to know is, now say this in this reactivity series, they say the potassium comes at the first. That means the potassium is going to be the highest reactivity person who is going to react very faster than other elements. So that is how they have arranged. So let's go to the activity series. Now, you know how I learned activity series is, I have kept a song for that. Now, some people have a different song. I have a different song. Now, I'll say 2 songs. One song is everyone knows. Other song is a new song. That is combination of Sinhala words and all of them. Right. Now, how did I learn this? How I learned this, I used to say Kalu, Nangi, Kalave,
Mage Aliya. Okay, Mage Aliya. Okay, so we remember Kalu Nangi Kaleve Mage Aliya. Then Zaina Ferozage Siineke Pissu Ballek Hapua Kohaji Silva Pottayage gold. This is one way of learning. Other one is, please stop calling me a zebra. Instead try learning how copper mercury saved platinum gold. This is one way of learning. This is other way of learning. So Kalu and please. So Kalu and please, we say potassium. So potassium only K. Okay, please potassium. Then Nangi, we say it as a symbol. Sodium. Here it comes as the spelling. No, this comes as a spelling. Please potassium starts with P. No, but here Kalu comes as a K. Potassium. Then sodium. Then calcium. Then magnesium. Then aluminium. Then you have zinc. And then you have the iron. That's what they have given as instead, iron. But I have given it as a symbol, iron. Then you have the stannum. You have the stannum, SN, the tin, stannum. Pissu Ballek, PB, that is lead. Learning on lead. Hapua, how? It comes as a hydrogen. Copper, comes as a copper, Cu. Haji, mercury, Hg. Silver saved. So they say saved means silver. Okay, so we say what? Silver, we take it as Ag. Right? And then you get it as Pottaya, then platinum, that is Pt. And then finally, gold, Au. This is how you remember. So I have given you two ways where you can do in both ways. Okay. So those who haven't by hearted the activities series, you can keep on working with that. Right. And some people, they on go with this way, and some people can go any way you want. Right. Okay. Some people has given me different way. Please stop calling me zebra. Instead, try learning how cucumber makes silver, platinum, and gold. That doesn't make sense, but okay. Right. Okay. Now this is very famous also. These songs, Kalu Nangi Kalave, this is very famous. And when we was doing all of us also, we did. Sinhala sirs no usually do the science and all. So those time we used to learn in this way. And this is the latest one. So you can learn any way you want. And however, you can by heart. Try to by heart. Okay? Right. Okay. Now let me write this activity series properly only with the symbols. Okay, so let's write the activity series and let's go on. So K, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, then you have this mercury, then you have then this one silver, then platinum, gold. Without the song, it's hard for me to do it. Right. Anyways, now when you talk about this, you have to memorize this in order. So now let's talk about this activity series and listen to me very carefully. Now, when you talk about these three, sodium, magnesium, calcium, listen. Sodium, magnesium, calcium are the elements. These elements, what do? Is these elements are the highest reactive metals. They are highest reactive metals. These people, we call them as what? Highest reactive metals. These are the three elements, right? And they can easily react with other elements
to form a chemical reaction. Okay, now when you talk about these potassium and sodium and calcium, so potassium, sodium, calcium, these three people are there, and these three people, they can react with cold water. So let me mark it over here. So they can react with cold water. These cold water, these three people can react with cold water. Listen to me, these things are much needed. So potassium, sodium, calcium, they are the highest reactive metals in the activity series, and they can react with what? Cold water. So when I take from sodium to magnesium, if I talk about sodium to magnesium, look here, sodium to magnesium, they are readily react with oxygen. They can readily react with what? Oxygen. Sodium to magnesium, they will nicely react with oxygen with a small amount of heat, right? So when you talk about magnesium, has a speciality that magnesium will react with hot water. It will react with hot water, as well as it will be reacting with a steam. It will be reacting with the steam. Okay, clear with that? Right. Next one. So when you go down, when going down the group, going down the group, the reactivity will be decreasing. Right. So now what you need to understand is from aluminium to copper. From aluminium to copper, you need to understand that these people will react with oxygen. These people, potassium, sodium, calcium, will react with cold water. Rest of them will not react with cold water. From aluminium to copper, they will react with oxygen with high temperature. High temperature. They will react with oxygen with a high temperature. Right? Then when you talk from aluminium to the lead, aluminium to the lead, aluminium to the lead, they will react with steam. They will react with steam. They will react with steam. Clear? Is my chart is clear? Is my chart is clear? I'm going a bit patiently because then only you can see. So from aluminium to copper, they will be reacting well. That means they will be reacting with oxygen with a high temperature. From aluminium to the lead, they will be reacting with steam. Clear? Got it? Okay. From hydrogen to the gold, they will not react with steam. They will not react with steam. From hydrogen to the gold, they will not react with steam. From copper, sorry, not from copper, from mercury to the gold, from mercury to the gold, they do not react with oxygen even though you give the high temperature. Even though there is a high temperature, even though you give the high temperature to react, they will not react with oxygen. Clear with that? Clear with that? Understood? Is this chart is clear? Is this chart is clear? Yes or no? Yes or no? Yes or no? Right. Okay. Then I'll continue. Listen. From potassium to hydrogen. From potassium, mercury. Hg is mercury. From potassium to hydrogen, remember, they will react with hydrochloric acid. From potassium to hydrogen, they will react with hydrochloric acid in order to produce hydrogen gas. In order to produce hydrogen gas, from where to where? From potassium to hydrogen, these elements will be reacting with hydrochloric acid in order to produce what? In order to produce hydrogen gas. Okay. From copper to the gold, from copper to the gold, they do not react with hydrochloric acid. Clear with that? They do not react with hydrochloric acid. Remember, from potassium to the hydrogen, I told you hydrochloric acid. No, what kind of hydrochloric acid is dilute? Dilute acid. They will react with dilute acid. But from copper to the gold, they will not react with dilute acid. If I move the light, it won't be visible. The board will be like dim. Can see now? Dilute, dilate. Dilate is different. Dilute is different. Dilate means it's like it's bent. We say in another term in English, dilate means like bent.
Don't make it too bright. Okay, give me a second. I'll check whether this bright is okay. I will reduce the brightness. Now, this one is okay. Earlier one is okay or now? If I off, it will be like this. If I on, it will be like this. Earlier was better, no? Then only you can see the board. If it is off, it won't be like, if I turn it off, you will feel sleepy. Because dim can make you less active. That's what when you sleep, you switch off the light. Why? You will be going peace. Right. Okay. So what I told you, from copper to the gold, this will not react with dilute hydrochloric acid. Clear? Clear? Yeah, copper to the gold, it will not react with hydrochloric acid. Clear, right? Got the idea, right? Okay. Now after this, once done writing all these things by yourself, now we have to study about how to balance equation. Okay. Shall we learn how to balance equation right now? From 8:30 to 9:10, we will have the break. PT is platinum. Okay. 12 was okay. Let's continue. Okay. Now we are going to study about balancing an equation. So we are going to study about what? Balancing equation. So let's study about balancing equation. So when we are talking about balancing equation, listen to me. Okay, now listen. Now I'll teach you how to balance the equation. Now imagine you have a scale. Imagine you have a scale. Okay. Sn is tin. Pb is lead. Right. So imagine I have a scale. So now in this scale, now say you have the old people, they used to have this kind of scale. No? You may have heard about this kind of scale, right? Okay. So now we have this kind of scale in the usually in our old days, right? So even now we can see when we see some what do you say, fisherman and all of them who sells fish. So we will see this kind of scale only. So now imagine about scale. Now, so if I put 2 kilogram in one side, if I put 2 kilogram one side, okay, and can you say to make both side equilibrium? If I want to make both of this side equal, what should be the other side value? To keep it equal, what should be the other side value? The other side value also should be 2 kilogram. So now what is balancing here? So balancing means if your right hand side also having the same amount of value, the left hand side also should have the same amount of value. The same thing you are going to do with what? You are going to do with the chemical equation. Now let's talk about some chemical equation. Now listen. Now we are going to study how to write equation. Now let's say, for example, potassium is going to react with oxygen. Potassium is going to react with oxygen. Now can you tell me what is the valency of potassium? What is the valency of potassium? The valency of potassium will be +1. What is the valency of oxygen? Oxygen will be -2. So let's forget about the signs and let's exchange. So once you have start exchanging, the 2 will go to the potassium, 1 will go to the oxygen. So therefore our answer will be K2O. Answer will be K2O. Now look at this. Look at this equation. This is going to be our left side hand and this is going to be our right hand. Now in this case, nicely plot and see, if I take potassium and oxygen here also you have potassium and oxygen. How many potassium do I have in my left side?
How many potassium do I have in my left side? 1. How many oxygen do I have in my left side? 1. How many potassium do I have here? 2. I have 2 potassium. And then how many oxygen do I have? How many oxygen do I have? I have 1 oxygen. There's a small thing I have to tell you. There's a small thing I forgot to mention. Whenever we mention oxygen in a chemical reaction, we will mention it as O2. We will mention that as what? O2. So that means now what will be the amount of oxygen? What will be the amount of oxygen? This will be 2. This will be 2. Now our answer is going to be, now are the left side and the right side is balanced? Is that balanced? Right side and the left side, is it balanced? It is not balanced. So since it is not balanced, what are you going to do? You are going to balance them. So how are you going to balance is by using multiplication. Always remember, in balancing equation we have to always use our even numbers. Even numbers can help you to cover the balancing equation. Now tell me, how can I make this potassium 1 into potassium 2 multiply by what number? Multiply by what number? I can multiply by 2. Since I multiplied by 2, I can add this 2 in front of potassium. So 2 potassium, 2 oxygen. Now here, how can I make this oxygen 2? How can I make this oxygen 2? Can I multiply it by 2 and put that as a 2 here? Can I put at the end of the 2? Can I put it as the end of this compound? Remember, whenever you are applying a chemical formula, balancing chemical formula, you can't put the value in the center of the compound or end of the compound. That is strictly warned, that you can't put any values in center of the compound, or you can't put at the end of the compound. Always it should be in front of the compound. So if it is in front of the compound means I have to add a 2. What should I do? So since it is 1 oxygen multiplied by 2, that means that 2 I have to put in front of where? I have to put in front of the potassium. So if I put this 2 in front of potassium, oxygen 2 will be balanced. 2 into 1 oxygen is 2. But here you have already 2. 2 into 2 is how much? 2 into 2 is how much? The potassium value will be 2 into 2 will be 4. That means if I put this 2 here as a potassium, will it be correct? If I put the 2 here in front of the potassium, will it be correct? No. Since we know the potassium is alone, can I put 4 in front of this potassium? Yes. So 4 potassium here, 2 into 2, 4 potassium here, and 2 oxygen here, 2 oxygen here. Are they balanced? Are they balanced? Are they balanced? Yes or no? Are they balanced? Yes, they are balanced. Now, let us use another example. Let me use another example. See whether you can do it. Okay, you all have to use your brain and you all have to do it. Okay, right. Now listen. Now say for example, sodium is going to react with oxygen. Sodium is going to react with oxygen. What is the valency of sodium? What is the valency of sodium? You can't use fractional numbers. Only even numbers are allowed. Okay. Now, what is the valency of sodium? +1. What is the valency of oxygen? -2. So, if you exchange, your answer will be Na2O. Na2O. Now, look at the right hand side and the left hand side. In the right hand side, what are the elements we have? Sodium and oxygen. Here also we have what? Sodium and oxygen. So how many sodium do I have in the left hand side? How many sodium do I have in the left hand side? 1 sodium. How many oxygen do I have in the left hand side? I have 2 oxygen. How many sodium do I have in the right hand side? 2. Oxygen is 1. Now see, these 2 people are individual. So I can put directly whatever the numbers in front because it won't affect anyone. But this one is a compound. No. Since it is a compound, you have to think, if I put whatever the numbers, it can affect the other number. So you have to think well and you have to do it. Now listen. Now, how can I make the sodium 2 and here 1? What can I do? What is the best way I can make this sodium 1 into 2? What should I do? I have to multiply it by 2. I have to multiply it by 2. So if I multiply it by 2, say for example, I have put a 2 in front of the sodium. So I have put a 2 in front of sodium is okay. 2 sodium and 2 sodium is okay. Now look here, oxygen is 2. If the oxygen is 2 here, oxygen 2. And how can I make it 2? I have to multiply it by 2. Can I put at the end of this compound? Can I put the 2 at the end of this compound? Can I put from the center of this compound? I can't put. So since I want to make the oxygen value as 2, what will I do? I will add the 2 in front of the sodium. If I add, what will happen to the sodium value? The value of sodium will be changing as what? 2 sodium into 2. 2 into 2 will be, sodium value will be 4. So since it is 4, what can I do? The other side also I have to turn into 4. So simply, if it is 4 sodium here, I can add a 4 here because sodium here is alone. Got the idea? Got the idea? It's all about calculation. It's all about mathematics, a kind of logic. You have to think and do it. Understood? Okay, let me give you one. See whether you can do it. See whether you have done it correctly. Say for example, magnesium is going to react with oxygen. Can you do the balancing for this? Find the chemical formula and do the balancing. Okay. Very good. Most of them sent me correct answers. Okay. Well, how we can do? Magnesium is plus 2. Oxygen is minus 2. 2 and 2 can be cancelled because it can be simplified. So our answer will be MgO. MgO, right? So since it is MgO, what we can do? Our answer can be magnesium plus oxygen 2 equals to MgO, means magnesium is having 1, oxygen is having 2, magnesium here is having 1, and oxygen here is also 1. So what I can do is, to make the value of the oxygen to be 2 as a equal, I am going to multiply it by 2. So can I put in the end? No, I have to always add in front. So if I add in front 2 MgO, since it is a 2 MgO, nicely think, magnesium also getting 2. So can I keep this magnesium blank? Can I keep this magnesium blank? No, I have to keep this magnesium with another 2 in front. So this is the balanced equation. Clear? Clear? Understood? If you put a 2 here, this 2 will be belong for magnesium. Also, it will be belong to the oxygen node here. So it will be balanced to this one. It will be belong to this one. It will be belong to this one. So if they are belong to all 2 of them means, so if this side is magnesium 1 means, I can multiply it by 2 by putting a 2 in front of this magnesium to make it balanced. No, isn't it? Clear with that? Understood? Okay, now let's talk about, now this is all this time we were talking about the reaction with oxygen. No? All this time we were talking about the reaction with oxygen. Now let's take something a bit complicated than this. So reaction with water. Yeah, I will talk about it. So when you talk about reaction with water, so reaction with water, we are going to study about the reaction with water. Now say for example, potassium is going to react with water. Potassium is going to react with water. Now potassium, what is the valency? +1. Water +1. Hydrogen is +1. Oxygen, I mean, like you have the hydroxide, no? Hydroxide is going to be -1. So potassium and hydroxide combined together, you will form what? Potassium hydroxide. You will form what? Potassium hydroxide. And then I will write that clearly, then only you will understand. So potassium going to react with water, right? So potassium valency is +1. So what are the ions present in the water? H plus ion and OH minus ion. So potassium and OH minus ion combined together, they will form potassium hydroxide. Okay, listen. Now, since you have hydrogen, do you find H1 in the nature or do you find it as H2 in the nature? If they are finding alone, if they are alone, do you find H1 in the nature or H2 in the nature? Usually, hydrogen will be found as what? H2. So, therefore, you will mention it as H2 gas. Right. Now, our chemical combination is done. So, once the combination is done, you have to see whether they are balanced. How do we see? Left hand side, you have potassium, you have hydrogen, you have oxygen. Here also you have potassium, hydrogen, and oxygen. One hydrogen, so one potassium and one potassium is balanced. See, you have two hydrogen this side, and you have one hydrogen. Sorry, you have two hydrogen this side. Okay, that is also balanced. And then here, how many oxygen do you have? Here you have one oxygen, and here you have how many oxygen? You have one oxygen. Are they balanced? Good, good, good. Wait. I did a small mistake because H3 here you have two hydrogen plus hydrogen, three hydrogen together. Now, yeah, you have three hydrogen together. Now, what is happening? Here two and here three. It is not balanced. Now we have to think how we can balance this. So, think well. Here you have two. Okay. Here you have three. So what we can do is we can make it, what is the closest value to 2 and 3? What is the even number that is closest value to 2 and 3? Okay, some people are saying me 6 and some people are saying me 4. Let's see which will win. Listen to me. Now what you have to do is, now you have this 3, you have 3 hydrogen. So what you have to see is you have to find it in a even number. So if you are finding it in even number, what I can do is nicely think, if I have 2 hydrogen here, and if I had a 2 in front of this, now how many hydrogen will I have here? How many hydrogen will I have? Totally 4, no? I will have 4 hydrogen. How many potassium will I have? How many potassium will I have if I add 2 here? 2. Can I add a 2 in front of this potassium to make it balanced? Can I add? Yes. How many oxygen will I have? I have 2 oxygen. So that means what I can do? I can add another 2 in front of this hydrogen. 2 into 2. Here 4 hydrogen. 2 into 1 oxygen is 2 oxygen. So am I balanced? Am I balanced right now? Think well. Yes, I am balanced. Clear, right? So most of them told me, I asked you a question, what is the even number that is closest to 2 and 3? 2 and 3. So what should be your answer? 4, no? You all went to 6. You all forget about the 4. 4 is also even number. Right. Right. Clear with that? Shall I give one? Can you give a try? Shall I give one? Can you give a try? Okay, then we can right. Sodium going to react with water. Give a try. Sodium going to react with water.
Tulosh is correct. Others? Aisha, double check. Shafni also double check. Releasing 2 electrons. I didn't understand the demon. Zara correct. Zara correct. You all have to give me the balancing, huh? Okay, we'll do it and see. Before the break, we'll do it and see. Look here. Now I will teach this. I'll give another one. You have to see. Until you get it correct, we will do it. Listen. See. Sodium with hydroxide. Sorry. Sodium is reacting with H2O, right? It is reacting with H2O. So what is the valency of sodium? +1. What are the ions present in water? H plus ion and OH minus ion. So that means sodium will react with hydroxide. So you will get sodium hydroxide. Do you find H1 in the nature or H2 in the nature? Do you find H1 in the nature or H2 in the nature? You find it as H2, no dear. So you have to think about that. Now listen. Now when you take the left hand side and the right hand side. Now let me take the left hand side. Sodium 1, hydrogen 2, oxygen also 1. So here how many sodium do we have? We have 1 sodium. How many hydrogen? 3. 1, 2, 3. We have 3. We have 3 hydrogen. So 3 hydrogen. And then again, how many oxygen? We have 1 oxygen. Now, I already told you. What is the even number that is close to 2 and 3? 4. So, are you going to put 4 or are you going to break it as 2 and you are going to put? You are going to break it as 2 and you are going to put it. So, what you are going to do is you are going to add a 2 in front of the sodium hydroxide. So, if you add a 2 in front of sodium hydroxide, 2 into hydrogen is 2. Here 2 hydrogen. Here 2 hydrogen. Totally 4 hydrogen. 2 sodium, 2 oxygen. So, since 2 sodium and 2 oxygen, you are going to add a 2 in front of the sodium. Sodium is balanced. And then you are going to add a 2 in front of the water. 2 into 2 will be 4 hydrogen. Here 4 hydrogen balanced. 2 oxygen will be balanced. Clear? Understood? Okay, right. Okay. Let me give you one more. Let's see whether whoever got wrong, give a try. Whoever got wrong, give a try. Calcium is going to react with water. Shafni is correct. Sarah, double check. No, Aisha. Joanna, you have to double check. Shahid, double check. There's small mistake. Okay, we'll discuss. Look here. So calcium is +2, no? Calcium is +2. Okay. And what are the ions are present? What are the ions are present in the water? H +1 and OH minus. So what is our final answer? 2 and -1 exchange. You are forming calcium hydroxide. Calcium hydroxide plus you will have hydrogen. So H2. So we have to see and we have to balance what? We'll see. Calcium 1, hydrogen here we have 2, and we have oxygen is 1. So since we know this will have a 2 arm, remember there will be a 2 arm. Calcium hydroxide, there will be a 2 under that. There will be a 2 under that. So listen. So here calcium, that's 1. Hydroxide, sorry, not hydroxide. Hydrogen, how many do we have? 2 hydrogen. 2 into hydrogen is 2 hydrogen. Here 2 hydrogen. Totally we have 4 hydrogen, isn't it? And then oxygen, how many do we have? We have 2 oxygen, right? To make, now who are we want to worry about? We have to worry only about hydrogen and oxygen. Do we want to worry about this calcium? Calcium is alone and here is alone, so you don't want to do anything. You don't want to worry about it. So what you have to do is, what is the closest value we can make this hydrogen into 4? You have to multiply it by 2. How can I make this 2 hydrogen into 2? Multiplied by 2. So we can add a common 2 in front of this. 2 into 2 is 4 hydrogen. 2 into 1 is 2 oxygen. Did you understand? Some people, they have put a 2 in front of this calcium. Did you understand why did you get it wrong? Because you have forgot to calculate this hydrogen 2 times and hydrogen here 2 times. That's the reason. Clear with that? Understood? Got the idea? Yes. Okay. Let's learn with chemical chemical reaction. That means chemical balancing equations with acids. We'll learn with acids. Now already we studied about oxygen. We studied about, no one understood. Okay, listen one more time. I'll let you know. So what did we use? Calcium plus water. No? So calcium plus 2. Remember, valence is plus 2. What are the ions are there in the water? What are the ions are there in the water? We have plus 1 and we have this one. Hydroxide, no. Hydroxide is minus 1. Okay. So calcium will react with hydroxide. It will react with hydroxide. So calcium hydroxide will come like this. You will get the value like this. So how do you write it? Calcium hydroxide 2 in bracket and plus H2 gas. Now, how in the sense? How do I get it? Calcium reacting with this hydroxide is a compound. It's a polyatomic ion. These two are together only. So if I write like this, remember this hydrogen, these two will only belong to hydrogen. Now, since it is a polyatomic ion, they are together, no? Can you separate and can you write it? No. So since they are polyatomic ion, you have to use a bracket to show these two belongs to both the hydrogen and oxygen. Hydroxide together, O and H together only, that is hydroxide. For those who are asking me about why did it come to there? Did you understand? So that's how you get it as calcium hydroxide plus 2 water. Then we saw that calcium 1, here calcium 1. Then how many hydrogen do we have? Here we have 2 hydrogen. Here 2 hydrogen. 2 hydrogen plus here 2 hydrogen. 2 plus 2. We have how many hydrogen? We have 4 hydrogen. And therefore how many oxygen do we have? Here we have 1 oxygen. And here we have this 2 also belongs to this oxygen. No, 2 into 2. Sorry, oxygen. 1 oxygen into 2 is going to be 2. So you have to just worry only about this set of people. So how can I make this 2 into 4? Multiplied by 2. How can I make this 1 into 2? Multiplied by 2. So this 2, you take it as a common person and put in front of this. So 2 into 2 will be 4 hydrogen. 2 into 1 oxygen is 2 oxygen. So here 4 hydrogen. Here also 4 hydrogen. Here also 2 oxygen. Here also 2 oxygen. Clear? Understood? How H2 came? Usually, do we have H1 in the nature or do we have H2 in the nature? Do we have H1 in the nature or do we have H2 in the nature? You say we have hydrogen gas, H1 gas, or H2. We say H2. H2. That's the reason we write it as H2. In nature, we can't put hydrogen normally. You have to put it with to show with this. Can I put oxygen 1 in the nature? No. You have O2 in the nature. Like that only you have to write. Clear? Understood? Right. Now you can go and take a break and come back by 9:10. Okay? And we can do the rest. Okay, welcome. Does calcium and hydroxide interchange their valency? Interchange their valency? Yes, they will interchange. That means calcium is +2, hydroxide is -1. So my +2 will go to the hydroxide, -1 will come to the calcium. You have to use the same link. How can you explain how OH came twice again? So now what is happening is -1, so calcium and -1 combining together, you are getting it as calcium hydroxide. So this hydroxide is not one word, it's a combination of two elements. So that 2 will come here. Plus, who is alone? Hydrogen is alone. Do we put hydrogen 1 or do you put hydrogen 2? Usually when hydrogen comes alone, you should mention it as H2. Understood? So here 2 into hydrogen is 2 hydrogen. Here 2 hydrogen. Together you get 4 hydrogen. Did you understand? Clear with that? I'll explain after the break because Avogadro constant, I'll tell you how is that working. Okay. Appreciating about it means a lot. All the very best. Okay, so shall we get started? So we have to study about extraction of iron, production of gases, and all of them. So yeah, in case if we can't start with the electrochemistry, I will be rescheduling with another date. So I'll update regarding that soon. Okay, whatever the details will be updated in my channel. Okay, right. Because I can't hurry the things because chemistry is like you have to do it in patience because certain things you have to remember. Even I have to repeat when someone doesn't understand. So because of that, time might consume. So yeah, if we can finish it earlier, then we can do it. Okay. Right, the class will be ending probably by 12. Okay. So yeah, we'll get on. I told I'll be mostly focusing on the changes in matter and electrochemistry. So we will be focusing more on that and rest we'll see. Okay, right. We'll start recording. Okay, so where did we stop? Actually, we stopped at balancing equation, right? So just to remember what we did last, let us do two questions related to the balancing equation, and then we'll move to the next part. That is very, very important. Most of us fail in that part when it comes to MCQ, right? Okay, now listen. So now what are we going to study is, now we are going to study about the reactions with acids. Reactions with acid. Now all this time we was balancing the chemical equation, that is with oxygen, that is with water. Now we are going to study with the acids. In case if you get any questions related to the acid, and you should be able to balance it, right? So because of that we are going to learn that. So reactions with acid, right? Listen. Now say for example, if any metals reacts with acids, remember, if any metals reacts with acids, they will always produce as a byproduct hydrogen. They will produce byproduct as a hydrogen. Now listen. Now say for example, sodium is going to react with hydrochloric acid. Now what is the valency of sodium? +1. What are the ions are there in the hydrochloric acid? H plus ion and Cl minus ion. So when you talk about H plus ion and Cl minus ion, sodium will be combining with the chlorine. So then sodium chloride. So you will get it as what? Sodium chloride. And then you will have hydrogen alone. Can you put the hydrogen alone? You can't, so you will put it as H2 gas. Now since you see here, can you say whether is this chemical equation is balanced? Is this chemical equation is balanced? So when I take here sodium, here you have one sodium, here you have one sodium. Okay, and then again if you take hydrogen, here you have one hydrogen, here you have two hydrogen. You have two hydrogen. So therefore again when you take about chlorine, here you have one chlorine, and here also you have one chlorine. Now look at the hydrogen. Hydrogen is not balanced. Since the hydrogen is not balanced, what are you going to do? What are you going to do? So since the hydrogen is not balanced, you have to multiply this side by 2. So if I am going to multiply this side by 2 means I have to add a 2 in front of this hydrochloric acid. Now hydrogen and hydrogen is balanced. Now again you are getting a 2 in front of chlorine. So if the chlorine is getting a 2, so I have to add a 2 in front of the sodium chloride. So that means the sodium also will be receiving a 2. Clear with that? Clear with that? Understood? Got the idea? Now, if I give one question, will you be able to do it? If I give one question, will you be able to do it? Okay, I'll explain one more time. Listen. Now, initially, what is there? Initially, you had sodium. Sodium is reacting with hydrochloric acid. So valency of sodium is +1. The valency that is present in this compound is H plus ion and Cl minus ion. So now what is happening? The sodium will react with the opposite charge, that is chlorine. They will be forming NaCl. And the hydrogen will be alone. No, so what will happen? You will have H2 gas. You can't put H1, right? You can't keep it as hydrogen. So you have to keep it as H2 gas. Now listen. Now we have to see whether they are balanced. If they are balanced, what you have to put? Now this is very basic what I'm talking about. You can put a dot line. See, this is left hand side, this is right hand side. So if it is a left hand side, you put it as sodium and hydrogen and chlorine. What are the elements are there? You can put it. Here also sodium, hydrogen, chlorine. How many sodium do we have? 1. How many hydrogen do we have? 1. How many chlorine do we have? 1. This side, how many sodium? 1. How many hydrogen? 2. So how many chlorine? 1. Now since this is going to be our problem. So this is going to be our problem. So here 2 hydrogen, here I have to make 2. That means I have to multiply by 2, means the number that you are multiplying should be added in front of the compound. In front of the compound. So if I add 2 in front of this hydrogen, again you have another person also with the hydrogen. Who is that? Chlorine. So chlorine also will get a 2. That means the value will be changed. So if the chlorine comes as 2, if the chlorine is here 1, what you should do? Here also you should multiply by 2. Here also you should multiply by 2. So now once you multiply here by 2, I have to add a 2 in front of this compound. I can't add in the middle. I can't add in the last because it is not
permissible for us to do it. So we have to add it in front of the compound. Now who is getting the 2? Sodium also getting a 2, chlorine also getting a 2. So these two people are balanced. Now again, this side sodium having 2 and here it is 1. You have to multiply it by 2. So you have to add a 2 in front of what? In front of sodium. Clear with that? Clear with that? We can't add at the bottom. It is not possible. And at what end product turning to like G liquid, it should be, it is compulsory for you to mark it as G. The reason it is shows as a gas. Clear? Okay, let me give one. Quickly try to solve it out. Try to quickly do it. Magnesium reacting with dilute sulfuric acid. Sulfuric acid. Should we show how the way the balance the equation? No need, but I'm just showing it because you need to understand. Can you do this? Give a try. Right. Okay. Did you have anything to balance? Did you have anything to balance? So since we see here magnesium is +2 here and here H plus ion here and SO4 2 minus. That means the valency for the sulfate is 2 minus. So this and this -2 plus 2 will cancel out. You will get it as MgSO4 plus H2 gas. So since we see there's nothing to change, same for same magnesium, same hydrogen. So when you have a balanced equation already, do you want to change anything? No need. Clear? Understood? Right. Now everything is done. Balancing part I have taught you and you have to do it by yourself, and this is what the balancing comes. Nothing is hard. This is how the balancing will come. Other than this, no balancing will come that will be complicated than this. Right. Okay. Right. Someone was asking me, magnesium SO4 liquid or a gas? Magnesium is a solid. Magnesium sulfate is a solid. Okay. Right. Now, okay. Now remember, like this. Now we are going to study something very, very important. Okay. Now, let's say, for example, now most of the MCQ question. I don't know whether you have seen such MCQ question. Imagine. They have given you something like this. X plus Z N SO4. And find who is that element. 12, Zahara. And find that X element. Have you come across with this kind of question in your term papers? You have to find the X. And they have shown something like this. Say, for example, most of the time you have come across with this kind of questions, no? And you will like think, okay, what is that question? What is the answer? You may think, no, I'll give you a tip. Okay, now listen, I'll tell you a story. Now let's say magnesium is there, right? Imagine magnesium is there. Now magnesium is going to react with zinc. Imagine magnesium is going to react with zinc sulfate. It is going to react with zinc sulfate. Okay. And zinc is going to react with magnesium sulfate. Imagine zinc is going to react with magnesium sulfate. Okay. What are the two incidents we have? One incident is magnesium is going to react with zinc sulfate. Zinc is going to react with magnesium sulfate. Now listen, I'll tell you a story. Now remember, now say for example, this is your home. Okay. This is your home and this is the area. This is the home area. Okay. So in your area, you have a politician. Say for example, next to your home, there is a politician. Now you know who is the politician, right? So you have a politician near your home. So when you talk about politicians, now they are higher than you or they are lower than you. Politicians, let's say the person like ministers, like if you compare myself with a minister, who are they are higher than me. I mean, with the work, the work they do and everything is higher than me. Now let's say near your house, you have a house or you have a land. Say for example, now this land is belong to you. Land is belong to you. And closer to your house only, this politician also living. Imagine like that. Now let's say near your house, you have a house or a land, something like that, which is needed by the politician. Now say this politician says, I like this land. So the politician like your land now. Imagine the politician like your land. Okay, so those land needed by him. So what he will do is he will blackmail you or he will show some legal documents and saying the land is not for you. What he will do? Now imagine, will politician come to your home and say, knock your door, I'll give you money. I will give you money. What he will do? I will get this land. Will he do like that? Most of the time, what he will do is he will say that he will come to you and he will show some legal documents and say that the land is not for you. It is government. So can he replace you? Can he replace this and say, this land is mine? Now he is in a government. He's a politician. He belongs to the government. Can he bring some legal documents related to this land and saying that is his land, not mine? So can he do like that? Yes, he can do because he's working there, right? So since he's working there, he can do. So no, can you be replaced? Can you be replaced? Saying the land is not yours, that is his land. Can you be replaced? Yes, you can be replaced. So can he take your place and keep you out? Can he take your land and put you out of the land? Can he do that? Yes or no? He will take you, you go out of this land. Now this land is mine. He will. So what you understand is the people in higher level take others' property of people in the lower level by force or by something. Did you understand what I told you right now? Did you understand what I told you right now? You have watched films, no? In the films, we have gone through that what do they do? The people at the higher position, what do? They will take the properties of the lower people and they will say, this is our land, that is not yours. So what do? They will say, this land belongs to us and to the government. They will take. So same like that only, the reactivity series. Can you remember the activity series? So if any element above activity series, can they displace? Can they displace? Yes or no? Yes or no? In activity series, you have potassium, sodium, and who is above the potassium? Who is above the sodium? Who is above the sodium? Potassium is above the sodium, right? Can the sodium be displaced by potassium? Can the sodium be displaced by potassium? Yes or no? Can the sodium be replaced? Think replaced. Can now say potassium is a politician. Potassium is a politician. Sodium is you. Okay. Can potassium displace you? Can it displace you? Yes, it can displace. Now, did you understand my statement? Did you understand my statement? Clear with that? So, same like that, in the activity series also, whatever the element is above and whatever the element is below, the above element will displace the below element and send off. Did you understand? Did you understand? Got the idea? Got the idea? Understood? Right. Listen, what are we talking about is when it comes to activity series. Now, listen. Now, in your area, there is a politician. In your area, there is a politician. Okay. And you have a land that is belong to you. You have a land that is belong to you. The land is liked by this politician. Will he come and say, I'll give you money and he will legally buy from you? No, right? He doesn't like to spend on you. So what he will do is, he's a under government person. Now what he will do is, he will prepare some fake documents saying that this land is not belong to me, and he will try to take the land illegally from his side. So this is the truth, because politician is the highest person. Can I go and fight with him? If I fight with him, next day a white color van will come and kidnap me and go, and they will kill me. So that is what happens reality, no? Same like that, in the activity series, the elements above the activity series are powerful, while the elements below the activity series are not powerful. So above people, what do you know, what will happen is, the elements above the activity series will displace the below people. Clear with that? Understood that? Got the idea? Okay, now look at this activity series. And initially, now look here. Magnesium is above or below? Magnesium is above or below? Magnesium is above or below? Talk about magnesium, will you? Magnesium is above or below? It is above. Magnesium is above. Above whom? Now think about the zinc. Zinc is below whom? Zinc is below. Zinc is below. Now think, I'm going to tell you a story. Same like that. Magnesium is above, zinc is below. Now imagine. Now what is going to happen is, magnesium going to react with zinc sulfate. Magnesium is going to react with what? Zinc sulfate. Now what will be our next reaction? I just wrote, okay? Okay. So now what is happening is, magnesium will go and react with zinc and put the zinc out of the house, and he will come to the house. Who will come to the house? Magnesium will come to the house of zinc, say this is my house, and zinc will be out. Did you understand? Did you understand? So in this reaction, magnesium can take the place of zinc, but look at this. Did you understand? Did you understand? Clear with that? So remember, whenever a magnesium comes out, now remember, whenever they give a question and whenever they have given X to you like this, what will be that? Sulfate is the land. Sulfate is the land. Huh? Now we are talking about the elements. No, we are not talking about the polyatomic ions. No. So if it is polyatomic ions, then I can talk about the sulfate. Now we are talking about the elements, powerful, the power of the elements here. We are talking about that. That's the reason the sulfate is not included. So if they have given you X next time, what will be that? What will be that? Which element will it be? The person who is at the above. The person who is at the above, then the zinc will take place the value of X. Clear with that? Clear with that? Okay. I'll give you something too differently. Now say for example, look at this. Zinc plus any element. If they have given you something like this. Now let me ask you a question, will you? O-level question. 2021. They have given X like this, and they have given you 4 options. Option number 1, they have given you iron. Option number 2, they have given you magnesium. Option number 3, they have given you hydrogen. And option number 4, they have given you what? Lead. Now which one will be your answer? Usually they will give you which is above that. Only one option is the answer is going to be magnesium. Did you understand? Clear with that? Got the idea? Right. Okay. I'll give you a different one. Look here. Now say for example, they have given you opposite. Zinc plus magnesium sulfate. Zinc plus magnesium sulfate. My question is, can zinc, now zinc is me. Magnesium is the politician. Now think, can I go to the politician house and can I take this politician out and say, this is my house? Can I say like that? No. Because magnesium is above in the activity series. So this chemical reaction will not take place. Now my question is, they can ask you, will this chemical reaction take place? This chemical reaction will not take place. Clear? Understood though? So next time, if they have given you something like this, you know the answer. Next time, when they have given you something like this, your answer should be the chemical reaction will not take place since the zinc is below the activity series on the magnesium. Clear? Clear then? Okay, now I'm going to test you. I'm going to test you. So now when it comes to test you, now tell me out those two chemicals and reaction, which one will take place and which will not take place. Okay, then. Okay. I have given you two chemical reaction. One chemical reaction will be taking place and other chemical reaction will not take place. Now you all have to identify which chemical reaction will take place and which will not take place. Okay. So how you have to answer me? You have to put me number one. Example. Take. Number two. Not. Simple, no? You can easily answer. Okay. So number one, copper plus zinc sulfate, zinc plus copper sulfate, which will take place and which will not take place. Very good, Joanna. Send me everything together, no? Then I can quickly say. All in one. Nicely think, what is our activity series? If you have the activity series, check that and also answer. Try to answer like that, okay? Shafni is correct. Afra check. Inzaman correct. Shima double check. Fatima is correct. Joanna is correct. Tulosh also correct. Then Batman check. Okay, shall we discuss? Shall we discuss? Now look here. So now when you talk about copper, is copper is below zinc or is it above zinc? Is copper is below zinc or above zinc? It is below zinc, no. Copper is below zinc. That means this is me means this is politician means. Can I go to politician's house and take the house? No, I can't take. So that means the chemical reaction will not take place. This one is me. Sorry, this one is zinc. Is above the copper or is it below the copper? Above or below? It is above the copper, no? Since it's above, it's going to be poly. And this is going to be me. Can the politician take my house? Yes, he can take place. Now understood how to answer? So this is how they will ask question in exam. So you have a metal X and you have some salt. Say for example, XSO4 they have given you and they will say you will have a metal Y and you have a salt of metal. Then what to do? Now let me explain you once again. Listen. Now in exam, you know how they will ask. Now say for example, they will say there is a metal X and you have a salt. You have the salt of metal X. You have the salt of metal X, that is X sulfate. X sulfate. And they will say you will have a metal Y. You will have a metal Y. And you have a salt of metal Y. And you have the salt of metal Y. You have the salt of metal Y X. Y sulfate. You have the Y sulfate. Okay. Then what do they say is they are initially put X with the salt of Y, and in the second reaction they are putting the Y with the salt of X. Say for example, they have given you something like this. Okay. So they have given you something like this. X is giving like this. Now say this is the reaction number one. Reaction number one is X giving XSO4. Then YSO4. Right. Now if they say this reaction in first place did not take place. If I say if the reaction in the first place did not take place and the second reaction took place means what did you understand from this? What did you understand from this? What did you understand from this? Now imagine I'll write the reaction also. The reaction is X by SO4 sulfate and Y XSO4 sulfate. Okay, now give me a second. Give me a second. I'll be back. Okay, so now what is happening is I'm saying that X is there. No? So X is one reaction. Second one is the Y is one reaction. So X is X sulfate here, Y sulfate you have. So now I'm saying that this is reaction number 1 and reaction number 2. Now if they say this reaction, first place did not take place, second place took place. That means the second reaction has happened. The first reaction has not taken place. Now, what did you understand from this is X is above activity series, or is it below activity series? This X should be below or above. If that does not take place, if it does not take place, is it above the activity series or is it below the activity series? Very good. So you need to understand the X is below the activity series. So that means, again, if I say Y had taken place means Y. Now what do you need to understand? Wait. We are doing a small mistake. The mistake, you know what? I told you the reaction did not take place. No. The X is the politician. So X is going to be the politician means the politician is above the activity series. Why is there? This took place because this is me. This is me who was below activity series. Now, did you understand where did we go wrong? Did you understand? The X is above the activity series. That's the reason I could not change. Did you understand? The Y is below the activity series. No. Wait, I am again confusing you. Wait. Right. Okay. I understood. So X, Y sulfate. Okay. I was a bit confused. Okay. Right. X sulfate. Right. Now imagine this did not take place and this took place. That means the axis should be below. If it is below only, that means this is me who is below than the politician. Because I am below the politician only, I could not take the politician's house. Now, okay, no? The second reaction took place because this politician is the person who is above the activity series. This is the politician. Can this politician take my house? Yes, he can take my house because X is below the activity series. Clear the? Understood? Got the idea, right? Right. So I itself create a question, then I itself confuse that question. Got it? Understood, right? Okay. Right. Now, have you come across with questions like this? Example, let me say you, they will give you a reaction like this. Imagine, this is also MCQ only. This is also MCQ. They have given a like this. Now all this time, what did we learn? From a balanced equation. Now from a balanced equation, you have to look at the number in front of the balanced equation all this time. Can you remember in your term papers, they have given you something like this: 4 aluminium plus 3 oxygen atom and 2 aluminium into 2, and they have given you something like this, aluminium oxide, and they will ask you to find the number of moles by giving a reaction like this. Have you come across questions like this? Especially MCQ, but rarely at the structure, and ask you to find the mole. Anyone got any idea how to do this kind of question? It's really hard. See this 4, 3, mole can't up. You will feel a headache, no? Because mole, where did it come? Chemical reaction is okay. Then you will think, where did this came from? Okay, now listen. Let me explain you how this is working. Listen. Now, let's come from the balanced equation. Now, that's the reason I told you, let's do the chapter 16. In the chapter 16, did you learn a lot of things? Because most of your MCQs comes from the chapter 16, because I know very well from where you get most of the chemistry questions. Not from the structure of matter, you get very simple questions, but the hardest questions comes from the chapter 16. So almost I have covered a lot of part that comes from your chapter 16, then you will be more confident to face your chemistry questions, right? Listen. Now, what did you understand from the balanced equation? What did you understand from the balanced equation? From the balanced equation, you have to look at the numbers in front. Now, what is the number? Now, imagine, let me write the same equation. 4 times aluminium plus 3 times oxygen atom over 2 times aluminium oxide. Aluminium oxide. Now, tell me, what is the number in front of aluminium? What is the number in front of aluminium? Very good. The number in front of aluminium is 4. Listen. The number in front of aluminium is what? 4. Now, that aluminium number is there. No? This number, this number, this number. The number in front of any compound, we say them as mole of that compound. We say them as what? Mole of that compound. Now, if I ask you, in the left-hand side, how many moles does the aluminium have? We write 4 mole. Clear? And how many oxygen, how many moles does the oxygen have? 3 mole. And how many mole does the aluminium oxide has? 2 mole. Okay, now listen. They have given you, if you have, what you need to understand is, you have to understand a kind of a story here. Listen, if you have 4 mole of aluminium, listen now, if you have 4 mole of aluminium, how many numbers are there in front of the oxygen? How many numbers are there in front of this oxygen? 3. Now listen. That means 4 mole of aluminium will react with 3 mole of oxygen. And what is the number in front of the aluminium oxide? 2. So we can say that 4 mole of aluminium will react with 3 mole of oxygen to produce, then to form 2 moles of aluminium oxide. Then what you have to remember is, with the balanced equation, we can equate the mole, or we can compare with the balanced equation. With the balanced equation, we can do 2 things. One thing is, we can equate the mole. We can equate the mole. That means we can compare the mole. Then we can even compare. Now, we can usually equate the mole. Okay. But you can't compare the mass. Remember, you can't compare the mass. You can equate the mole, but you can't compare the mass. Clear with that? Clear with that? Got the idea? Shall we do some sums, like your MCQ sums? Now you will understand. When you do some MCQ sums, you will get to know. Listen, I'm going to do a sum for you and you are going to understand. Right. Now listen. Listen. We are going to do a sum and we are going to understand this. Right. Now this, when I told you, you didn't understand because it's like a just aluminium. 4 mole of aluminium is reacting with 3 mole of oxygen to produce 2 mole of aluminium oxide. That's it, you know. But let's see, how does a question comes in your MCQ. Listen, I'm going to go very deep and you are going to listen to that. Listen. Now, do the balanced equation. Now, can you do the balanced equation for this quickly, children? Can you do the balanced equation? Sodium is going to react with oxygen. Can you do it? Now you are going to try with me, because now all this time I was doing lectures. No, now you was listening. Now you have to take your pencil out. You have to balance, huh? Nicely think and balance. Balancing is there here. Now I am connecting the grade 10 chapter 7. Huh? Some people ask me to teach the chapter 7. No, I'm I'm going to add this lesson here in between. Chapter 7 of grade 10.
quantification of elements. I will be connecting here. So that part also I'm completing. Because most of the time quantification of elements comes in this part. Okay, shall we do it? Listen, most of us didn't give me much answers. We'll see. Here, look here. +1, -2. When you combine, you will get sodium, Na, sodium 2O, 2 sodium oxygen. Now initially, can you see dear? Initially, you have 2 sodium. Initially, you have 2 oxygen. So if you wanted to think about it, nicely listen to me. How many sodium do we have? 1 here. How many oxygen do we have? 2 here. How many sodium we do have? We have 2. Here oxygen we have 1. So we have to equate both of this side. How can we equate? Now what is the common? Here also 2, here also 2. So if I add a 2 in front of this, just to make the oxygen as 2, what will be the value of sodium? What will be the value of sodium? 2 into 2. What will be the value of sodium here? 2 into 2. What will be the value of sodium here? The value of sodium will be 4. Now, did you understand where did you go wrong? It was like you were careless. That means you didn't see. You didn't see the other side. You didn't even calculate. Even though you had given me this answer, you didn't see other way. Should I equate or not? Should I compare or not? Should I see whether it's correct or not? You have to always balance and see. So balancing is very, very, very important. Right. Now we have done balancing. Now balancing is over. Now tell me how many more sodium do we have? How many more sodium do we have? We have 4 mole of sodium has been react with. Now how many mole of oxygen do we have? How many mole of oxygen do we have? We have 2 mole of oxygen. So we have 2 mole of oxygen. 4 mole of sodium has been react with what? Sodium. You all have to put a, you all getting a 2, right? Here also you should get a 2. Here also you should get a 2. Since I have put a 2 here, here you get a 2. So you will get a 2, no? Right. There's a 2, right? Okay. Here already there was a 2, no? So how many mole of oxygen? 1 mole of oxygen. 1 mole of oxygen. So 4 mole of sodium reacted with 1 mole of oxygen to form 2 mole of sodium oxide. Now listen, what did you understand? 4 mole of sodium reacted with 1 mole of oxygen to form 2 mole of sodium oxide. Now you all have studied in grade 10, unit 7. Can everyone say me, what is the equation to find the moles? What is the equation to find the number of moles? Number of mole equals to mass over molar mass. Now, in exam, they have given a question. I'm going to give a question which is usually given in your O levels. Okay. So let's say they have given, if there is 23 gram of sodium, okay, if they have given you, if there is 23 gram of sodium, find the number of mole of sodium, and they have given you the relative atomic mass as 23. Now, I have given a small question to you. How do you find the number of mole? Can you tell me what is the number of mole? So if I say 23 gram, so what is our equation? Mass over molar mass is our equation. So what is our mass here? 23. What is the molar mass they have given? 23. So how many mole? 1 mole. That means 23 gram of sodium has 1 mole. Did you understand? Did you understand? Clear with that? Now listen. We should write the units, right? Now what you have to understand means, now what you need to understand, now they have given you in exam, find the number of moles of sodium oxide that can be formed above sodium reacts with oxygen. Now what is the equation here is, now they have already given you something like this and they are asking you to find the number of moles. They are asking you to find the
number of moles in sodium oxide. Now already we combine sodium with oxygen and we form sodium oxide. Now you have to use the balanced equation and you have to compare. You have to use the balanced equation and you have to compare. I'll repeat again. Listen to me. Now initially we have balanced it. No, this is one step. This is the step one. This is the step one. Step two is now they are asking how many moles are there in Na2O. That means sodium oxide. They are asking you like that. How many moles are there? So to find the number of moles in sodium oxide, you are going to equate the sodium with sodium oxide. You are going to compare. So let's see how are we going to compare and how are we going to do it. Now listen to me very carefully and we are going to do it, right? Okay. Now listen to me very carefully. How are we going to do? So according to the balanced equation, if you have 4 sodium, how many moles of sodium oxide can you form? According to the balanced equation, if you have 4 sodium, how many moles of sodium oxide can you form? You can form 2 moles. So that is the ratio. That is the ratio. Now what is our ratio? So shall I erase this? What is our ratio? So what is going to be our ratio? So our ratio is sodium is to sodium oxide. Sodium is to sodium oxide. So what is our ratio? What is the number of sodium we have? 4 is to 2. So but now in this question, do you have 4 moles? Initially they told you what? 23 grams of sodium with relative atomic mass of sodium, that is 23, and you found the number of mole is equals to mass over molar mass 23. You found it as 1 mole, isn't it? Now the question is, for 1 mole of sodium, how many sodium oxide will you have? Did you understand my question? Did you understand my question? They are saying that, now say, I'll tell you an incident like this. Now, say you have 4 cake. 4 eggs. Say you have 4 eggs. Okay. Now, this is only 4 egg you have. Okay. By having 4 eggs, you can form 1 kilogram of cake. 1 kilogram of cake. Okay, understood. Listen. By using 4 eggs. That's what I'm explaining. Listen. So, let's say they are saying that now you have done a balanced equation. No, this is the heading. You have done a balanced equation. Now say for example, this is our recipe. In our recipe, they have told that if you have 4 eggs, you can make 1 kilogram of cake. Now, in our question, they are saying that you don't have 4 eggs. You have only 1 egg. Then you have to find that with 1 egg, how many kilogram of cake can you make? Did you understand? Did you understand what I told? So initially they are saying that. What do you need to understand? Initially, if you have 4 moles of sodium, you will have 2 moles of sodium oxide. That is the question. And they are saying that now we don't have 4 moles. We have 1 mole. For 1 mole of sodium, how many sodium oxide will you form? How many moles of sodium oxide will you have? Then, did you understand? Now, did you understand what I told? This is how you get questions in your O-level. Did you understand? Now come. Now, listen. Now, what did you understand? So, this is our recipe. In our recipe, 4 eggs, you get 2 moles. If you have 4 moles, you get 2 moles of sodium oxide. Now, do you have 4? Now, do you have 4? No, right? You had 1. The question, they had 1. Now, you don't know how many moles will be there. That will be coming as X. Now, can you remember you have learned something like this cross multiplication? Can you remember you have studied something called cross multiplication to find the value of X? When it comes to ratio, we can do like that. Have you learned cross multiplication? So, to find the value of sodium, what are we going to do? 4 multiplied by X is to 2. So now what are we going to do? Take this 4. What are we going to do? Take this 4. To make, you have to make this x as a subject. You have to make the x as a subject. Formula lesson, max. So when you take this 4 to the other side, when you take the 4 to the other side, what will happen? This will, multiplication 4 will come as a division. If it comes as a division, x will be equals to 2 over 4, which is comes as a half, which will come as a half. So what will be the value of x then? If it is half means, what will be the value of x? What will be the value of x? 0.5 mole. Now you understood. Now understood how to find the mole. If they give any questions in exam, something like that. Did you understand? Okay. Now those who didn't understand, listen to me one more time, because we don't have time to do everything. No. So listen to me. I'll explain you back again. Now, if you are good in maths, you would understand. And also, if you are not good in maths, also you will understand. Both motivation. Okay. Now we are going to make cake. Think like that. Okay. To make cake, you need egg and sugar. Imagine. So that egg only going to be the sodium plus oxygen, right? So combination of sodium and oxygen, we know they will form sodium oxide. Now we know that they are not balanced. I already told you how they are getting balanced. No. So we know this will be the balanced equation of oxygen. Okay, and this is the balanced equation of sodium and sodium oxide. Now accordingly, I told you that when it comes to balanced equation, we can compare the balanced equation to the mole, right? So that means how many moles of sodium do we have? We have 4 mole of sodium. And how many mole do we have? Do we have any values in front of this oxygen? No. So that is considered as what? 1 mole. So combination of 4 mole of sodium and 1 mole of oxygen, you are forming 2 mole of sodium oxide. That is the story. So our recipe is what they are saying, that if you have 4 mole of egg, imagine you have 4 egg. If you have 4 egg and if you have a bit of sugar, you will be forming a 1 kilogram cake. It's 1 kilogram cake. Okay, think like that. Now, in our exam, now they have given you something like this. The question they will be giving is, initially they will say, you have 23 gram of sodium. Initially, no, I'm just telling 1 kilogram. Imagine, I'm just telling it is as 1 kilogram. Imagine, don't think about this value, just think 1 kilogram. Okay. Now, say for example, you have 23 gram of sodium and they have given you the relative atomic mass in your exam as 23 gram. Find the mole that you have. Now they are asking you to find the number of mole. So if you are finding the number of mole, what is our equation to find the number of mole? What is our equation to find the number of mole? Number of mole equals to mass over molar mass. So what is the mass that they have given? 23 gram. What is the molar mass? What is the relative atomic mass they have given? 23 gram per mole. They have given like that. Okay, so this gram and this gram will get cancelled out. This 23 and this 23 will cancel out. So 23 divided by 23, how many do we have? We have 1 more. That means they are saying that you don't have 4 eggs. You have only 1 egg. So if you have 1 egg, how many kilogram of, that means how many moles of sodium oxide will you have? Did you understand? Did you understand? Clear with that? Yes. Anna, listen. Now our question is to find, if I have 1 egg, how many kilogram of cake can I make? That is my question. Same like that. If you have 1 mole of sodium, how many mole of sodium oxide only you will be forming? For this purpose, we will be learning the ratio. We will be using the ratio. How are we going to use the ratio? Sodium will come first. Egg no. From the egg no we are making the cake. So egg is to cake. So sodium oxide. Now sodium, how many mole sodium do we have right now in our hand? No, before that. Usually in our recipe, what is mentioned? How many eggs should we have? We should have 4 eggs. To have how many moles of sodium oxide? 2. So we have, this is the recipe. Now do we have exactly what is mentioned here? No, they are saying only 1 mole of sodium is present. So I am going to mention it as 1. And do I know how many gram will I have? Do I know how many cakes will I have? I don't know, right? So that's the reason I put it as x. So when I put it as x like this, you will get it like kind of a part of a ratio. Now what you will do? You will do the cross multiplication. Now cross multiplication means 4 will get multiplied by x, 1 will get multiplied by 2. So what will we do? 4 multiplied by x equals to 2 multiplied by 1. So 4 into x, 4 multiplied by x, 2 multiplied by 1. So 2 multiplied by 1 is 2. No? So what I'm going to do is taking this 4 to the other side. I have to simplify. No? So multiplication 4, if I take it to the other side, it comes as a division 4. So therefore, x will be equals to 2 divided by 4. So 2 divided by 4 will be 1 over 2. So 1 over 2, what is the decimal value for the x? 0.5 mole. So if you have 1 egg means you will get only 0.5 gram of cake. Did you understand? Like that, if you have 1 mole of sodium, you will have 0.4 mole of sodium oxide. Clear the another? Okay, clear no? Now listen. Now I am going to ask you, next question is, find the number of moles. Find the number of moles of oxygen reacting. Now let's find the number of moles oxygen is reacting. Now you have to compare sodium to oxygen. You have to compare the sodium to oxygen. Can you find the, can you compare and find? Now, like say for example, if I have 1 mole of sodium, how many mole of oxygen will I have? Can you find it? The same method I told you. Can you find it, please? Give a try. Give a try. No, relative atomic mass is not given. They are just saying you. Okay? Fine. Give me a second. Did you all find the answer? Did you all find the answer? Yes or no? My question, correct. Ifaza, very good. Tulosh, very good. No, Shafni, fine, you can. The question was, now initially, if you have 4 moles of sodium, you will have 1 mole of oxygen. No. If you have 1 mole of sodium, how many mole of oxygen will you have? The same method. Like the cake method I told you. Very good, Shafni. Very good, Reema. Sarah, double check, Sarah. Joanna, correct. What is the decimal? What is the decimal? Oh, very good. Samsung is very good. My question is very good, Joanna. My question is, I'll erase this. My question is, if you have 4 mole of sodium, listen, Shimar, very good. If you have 4 mole of sodium means you have 1 mole of oxygen. If you have 1 mole of sodium means how many mole of oxygen will you have? What is Arhab correct? What is our equation? Our equation is sodium. Now you have to compare. Comparing sodium is to oxygen. So sodium, initially we had 4 sodium means I will have 4 mole. If I have 1 mole of sodium, means how many mole of oxygen will I have? Cross multiplication. So if you cross multiply, 4x equals to 1. So it is like multiplication, no? 4 multiplied by x, no? Abdul Rahman, correct? So 4 multiplied by x is no. So division 4, if you take to the other side, sorry, multiplication 4, if you take to the other side, it comes as a division. So x is equals to 1 over 4 means, Asma, correct? So what is the answer? 0.25 mole, no? That's the answer. Clear there? In case, if you get any questions related to your O level like this, will you do or not? Will you do it or not? Did you gain confidence? Is that hard? Is that hard? No, right? It's easy. Interesting. Chemistry is interesting. Okay, it's like, you are like a detective. So you are like a detective and you are learning these things and then like you are giving 100%. Wow, this is interesting. Okay, shall we do another interesting part? Shall I give you a things? Yeah, starting will be hard, but when you learn, when you keep on going, you will understand. Okay, I'm going to give you 5 questions related to this. I mean, like one major question with 5 questions. Will you be able to answer? I'm going to give marks for you. Very good, Arhab. Great to know about it. Right. Okay. Anna, let's do a question. Let's say, for example, this is a normal model question. Let's give a try. Like every year, we use the same questions. Let's try. Okay. Now let's say 2.7. Don't get scared of the decimals. I already told you decimals are easy. Listen. 2.7 gram of aluminium was dissolved in 250 centimeter cube of dilute hydrochloric acid. Okay. The relative atomic mass of aluminium is 27. Remember the things, sometimes they give is unnecessary things also they will give. Like you should not get distracted by the unnecessary information, right? Okay. Number 1. Write the balanced equation that would take place. Right? Question number 2. Find the number of moles of aluminium dilute with water only, but don't take it as water. Just take acid. Don't think of water, just take acid. So find the number of moles of aluminium used. Same thing what we did only. Don't get confused. Try to give your maximum this time. No calculators also. Try your best. Next one. Find the number of moles of hydrogen gas used. Guys, now in this question, I didn't ask you 2.7. 2.7. In this case, listen, in this case, I didn't even ask a question to find the number of moles. So it is your duty to find the number of moles of aluminium and keep. Okay, understood. Initially in exam, they do not tell you, do this lamai, do that. They do not give you everything, like they do not feed you everything. So you should be a person, if they have given you relative atomic mass, means you should think they are automatically asking you to find what? Automatically they are asking you to find the mole and keep. So you should automatically find the mole of aluminium and keep. Okay, right. Question number 4. Find the number of moles of aluminium chloride, right? Then next one is question number 5. Find the 27. I'll write it here. Relative atomic mass is 27. Okay, find the number of moles of hydrochloric acid used. Okay. Now tak gala do. Tak gala do. Now think if they have given the relative atomic mass of aluminium means always you have to compare whom with whom. If they have asked find the number of moles of hydrogen used means whom and whom should be compared? Just tell me to check whether you are okay. Whom and whom should be compared? If they have given the aluminium's relative atomic mass means you have to compare aluminium mole and the hydrogen mole. Okay. Here also same. They have asked you the mole of aluminium, no? So they have asked you to find the aluminium. Now you can find the number of moles here. You can find the number of moles. Automatically, number of moles you can find. The rest can be done by you. Do. I want everyone to score 5 out of 5. Okay? You can do it. Do. I'll give you around 5 minutes. 5 minutes is too much time, but it's okay. We'll give you 5 to 6 minutes, will you? 5 to 6 minutes. Like 10:22, I will be discussing. Until that, don't tell me the answer. Keep working. The relative atomic mass is 27. So you have 3 minutes more. You can type the answers and keep, okay? Because I'll be correctly discussing by 10:22. So then only you will be able to do this kind of questions. No, you will gain confidence. And this is one of the important part in your O-level. Whatever is important to your O-level only, I'm doing it. Because other lessons, they do not have
much things in that. So instead of wasting time in that, that's the reason I told you I will be doing this lesson. Okay, so that's enough time. Shall we discuss? I could see some people's correct answers. Some people have made silly mistakes. Shall we see what is that? Okay, right. So we are going to discuss. So remember, if your first answer itself wrong means everything is going to be wrong. That means if your chemical equation balancing is wrong now, everything is going to be wrong. Okay? Okay, I will help you out. Listen to me. Right. Himar, your answer. So your answer is correct. Correct. First one is correct. Second one is wrong. You have made a mistake. Third one also you had made a mistake. So first one is correct. Then the other one, the way you have done is a bit wrong. I'll tell you why. Listen. Now, what you have to understand is, listen. First one is aluminium going to react with hydrochloric acid. So they will be forming what? Aluminium is +3, no? Hydrogen is +1, chlorine is -1. So aluminium AlCl3. And then you will have hydrogen gas as a liberation. Okay, right? Now listen. Now we have to see the balancing. If you see the balancing, you will get an idea. So how do we balance it? We have to balance it aluminium one time, hydrogen one time, chlorine one time. Here aluminium one time,
hydrogen 2. We have 2 hydrogen. And we have how many chlorine? We have 3 chlorine. Now, since you see that, what you have to do is you have to balance the chlorine. And you take, now I told you chlorine you cannot, now they have given 3, no, so I have to make them into a value that is even number. So even number, I have to try to make it to the even number. Let's see whether I can make the hydrogen into 2. Can't. So that means you can see here 2 and 3. So what is the common number? Multiplication. If you multiply 2 and 3, you get the answer as 6, no. So if I put the 6 as the answer for the both the side, you can be managed. We'll see how. Okay, let's see how. So what I'm going to do is I'm going to add the 6 in front of this hydrochloric acid. Okay, so 6 hydrochloric acid. Now again, when you look into that, now hydrogen here, chlorine here is 3. Can I make this 3 as 6? Yes, I have to add a 2 in front. If I add a 2 in front, 2 into what? 2 into 3 will be 6. Chlorine is also okay. Aluminium also will gain a 2. So I will put a 2 in front of that. Again, hydrogen, are they balanced? Hydrogen also should be 6, no? So I have to put a 3 in front of this hydrogen. Okay, understood. Got it? Okay. Right. Now listen. If you have done after long period of time by trying, if your chemical equation, balancing chemical equation, if that has come correct, then remember that means it is a victory. It's a victory, right? No worries. How did I get the 2? How did I get the 2 for the aluminium? The reason I got the 2 for the aluminium, because I have added a 2, because since I have added a 6 in front of this chlorine also should be 6, no, then I have to add a 2 to make it 6. That's the reason. How many moles of aluminium do we have right now? We have 2 moles of aluminium plus 6 moles of hydrochloric acid. That means 2 moles of aluminium combined with the 6 moles of hydrochloric acid to form 2 moles of aluminium chloride, and they produce 3 moles of hydrogen gas. Clear? That's the answer for the first one. Okay. Second answer is find the number of moles used in aluminium. Now, what is the value they have already given? The relative atomic mass of aluminium is 27. The aluminium value is 2.7 gram, the mass. So how can you write it? How can you write them out? So let me write them out. So number of mole equals to mass over molar mass. So what is the mass? 2.7 gram over 27. If you write like this is correct. Okay. So 2.7 over 27. What is our answer? Guys, think like 27 and 27. What's the answer? 27 and 27 is 1. No. If there's a point, put the point in front of that and put 0.1 mole. 0.1 mole. This is the mistake we all do. If it is 2.7, no, it is usually 2.7. 2.7 divided by 27 means, first forget about the decimal. Forget about the decimal. If you forget about the decimal, how many 27 is there in how many 27 is there in how many 27? I mean, how many 27s are there in 27? 1, no. So you will put that 1. Then initially you remember there is a decimal. So you put a decimal in front of that 1 and you have to add a 0. Clear that? Clear? Clear? This is how you manage, huh? Next time when you get any questions, you have to manage it. Okay. Question number 3. Question number 3. Find the number of moles of hydrogen used. Find the number of hydrogen used. So how do you find the number of hydrogen used? Now initially we found how many aluminium? What is the mole? What is the aluminium number of mole we have? We have 0.1 mole. Now they are asking for 0.1 mole of aluminium, how many hydrogen will you have? Now this is our recipe. No? By looking at the recipe, we have to compare. So aluminium is to hydrogen. Aluminium is to what? Hydrogen. Now listen, how many aluminium in the recipe? 2 aluminium in recipe. How many hydrogen is in the recipe? We have how many hydrogen? We have 3 hydrogen. No, when you talk about the hydrogen here, I'm talking about this hydrogen. Don't go with this. Don't go with this. It's a compound. Hydrochloric acid. This one, this hydrogen. How many mole? How many mole? 3. And what is the amount of mole that I have right now? 0.1. Do I know how many hydrogen is used? That is X. Cross multiply. 2 multiplied by X equals to 3 multiplied by. So your answer will be what? 3 multiplied by. We can take like this. So if you cross multiply that, we will take 3 multiplied by 0.3. So that means your answer will be 0.3 over here. Now what I can do? X is equals to 0.3 divided by 2. X is equals to 0.3 divided by 2. Now what you can do? What you can do is you have to divide it and you have to see. So how can you divide this decimal? If you can, very good, Shima. That's correct answer. If you're dividing, now those who doesn't know dividing the decimal, listen to me. You have to take something like this and 2. Okay, listen like this. So dividing, how many zeros are there in? How many zeros are there in 2? There is no 2's in zeros. No. So 0 into 2 is 2. Okay. Then it's a subtraction. No, since it is a subtraction, what you have to do? So you have to put the same value. You have to put the same value. So you will get it as what? Yeah, it's a 0. Yes. Yeah. 0. So now what happens? 0 into 2 is 0. Then again you will get the answer as 3 here. Then you will take an imaginary. 0. So it will be 30. It will be what? 30. Okay, correct, no? So it will be 30. How many 2's are there in 30? We have 15. So what will happen? How many decimals? Now, since I have taken, now already there is a 0.3. No, it is 0.3. How many numbers? That means there is an imaginary 0 also. No. So how many numbers after decimal? 2 numbers after decimal. So that means how will I go? I have to go with reverse, no? 1, 2. So answer is 0.15. Now there are people who can't do that. No, that's the reason I was taking time for that to answer that. Okay. So what's the answer? 0.15 mole. Clear with that? Clear? How did I get the answer for the third one? Yes. Okay, now let's go to the answer. Fourth question. Let's go to the fourth question. In the fourth question, they are asking you to find the number of moles of aluminium chloride. Now, initially, aluminium in the recipe is how much? Aluminium in the recipe is 2. Wait. Yes, 2. Is 2. Aluminium chloride in the recipe is how much? That is also 2. Now, initially, I have, what is the value of my aluminium that I have right now? 0.1 is to X. Now, what I can do? I will do cross multiply. No? So, if I cross multiply, what can I do? So, I will take that 2 multiplied by X equals to 0.2. So, take the 2 to the other side. That comes as the division. If that comes as the division, my answer will be 0.1 mole. Clear? Understood? Got the idea? Yes or no? Got it? Right, good. Let's go to the fifth one. Find the number of moles of hydrochloric acid. Now see, I have even created a question for you and I have given, because you have to get confident in doing such questions in exams. Definitely, I will tell you that this will come. One more then other things will be pending. No, we have to learn extraction of iron. That is very important. Extraction of iron is very important. I have to do that. So after this, I'm doing extraction of iron only. Okay. This one, what is the next one? Hydrochloric acid. Aluminium is to hydrochloric acid. So then you have 2 is to 6. 2 is to 6.
I'll talk about the electrochemistry now. I don't think so we can do, but we have learned a lot in this lesson, isn't it? And 0.1 is to x. If you go on with that, 2 multiplied by x is equals to 0.6. So therefore take the 2 to the other side. 0.6 divided by 2 will be, x will be equals to 0.3 mole. Okay there, who got all 5 correct? Yeah. Those who didn't understand, you all can just watch the same questions again and again using the YouTube. Okay? Right. Clear then? Understood. A new question. If I give new question, we will stick on to this itself, because now already we did know. This is one of the major question that I have taken from your O-level paper. So this is one of your O-level paper question. So if you have done it, everything, and if you have got correct, very good. And some days you know very well that. Okay, so you know very well some days there are some questions where you haven't understood, where you haven't even your school teachers didn't teach that. So now today if you have understood means you have to be happy. Okay, before exam I got a chance to understand this. So because you know in chemistry there are some hidden challenges, there are some hidden tricks and all, like every time, like whatever you learned in maths also will be connected here, like cross multiplication, fraction, everything will be coming. But since when you talk about the maths and science, science is very easy and interesting. Did you understand? Question number in what? It was like I gave a question that I remembered. Like every year I used to give such questions, no? So I just randomly gave a question to you in O-level papers. There was a question like that. I'll try to send it to you. Okay? Right. Shall we talk about extraction of iron? That is very important in your O-level. Extraction of iron. This comes to your O-level. Very, very important. That big jar will be there in that lesson. Okay, shall we talk about iron right now? So now listen to me very carefully. Listen to me. Now you are going to study how you are going to obtain iron from the earth. Now you are going to study how are we going to get iron from the earth. Now we usually use iron, but we don't even research how these ions are being produced, how these gems are being produced. We never know how does it look like from the end of the earth. We have to think about it, right? Now, when you talk about iron, the iron on the earth present in the form of ore. You know ore? Remember, iron on the earth is present in the form of ore. Kalli, we say stone, right? So when we talk about iron will be present in the form of ore, the big ore. Okay, it will be like ashy color, big ore. If you don't know, you can Google it and see the picture, right? So now this ore in science, we call it as hematite. We call this as what? Hematite. We call this as what? Hematite. We call this as what? Hematite. Now, the hematite, the chemical formula for the hematite in science is FeO. That means we call it as iron oxide. So iron oxide, what is the chemical formula for the hematite? That is Fe2O3 iron oxide. It means this is an oxide of iron. Okay, so what is the valency of iron? If you think, what can be the valency of the iron? Now imagine, listen. If the hematite is Fe2O3 means, what can be the valency of the iron? What can be the valency? Now, by exchanging the valency, you got this chemical formula. Now tell me, what can be the valency of the iron? Is that 2 is their valency or the 3 is the valency? What can be their valency? Very good, Ifaza Ahmad. Very good. Correct. Remember, by exchanging like this, you receive the valency as what? The person who has this valency will have the valency of iron. That is +3. Listen, when you talk about iron, iron have 2 charges. Iron have how many charges? They have 2 charges. One is +2 charge.
Other one we have the +3 charge. Okay, now listen. So the question was in this chemical formula, what is the ion, what is the valency they have used? The valency they have used is, listen, what if it happens negative? I'll tell you. Okay, now listen. So the question was in this chemical formula, what is the charge on the iron? Here, the charge on the iron is +3. Okay, so we found out that +3 is the charge on the iron. Clear? I will explain you why do we have this +2. But remember, iron has two charges. One is +2 charges and +3 charges. Initially, when you take the iron from the ore, the hematite will have the charge of +3. Clear? Understood? Got it? Okay, right. Now listen. Now we are going to produce iron. So now what is happening is, to extract the iron from hematite. That means hematite is there now. So when you have the hematite, what are you doing is, in the hematite, what are you doing here is, now listen. Now in this hematite only you are going to extract the iron. That means iron is inside this only. So you are going to extract the iron from this hematite to get the real iron. Clear? Now what are you going to here? You have to use an instrument called blast furnace. You have to use an instrument called what? Blast furnace. You may have seen this picture in your textbook. So we call this as what? Blast furnace. So we are using that, we call it as what? Blast furnace. So look here. Okay, so this is how it will look like. Outing. Okay, so this is how it will look like. I just drew, okay? Now what are you doing is, from the blast furnace only, you are going to do the extraction of iron. From top, you will add the raw materials. Now, you will be adding the raw materials from the top in order to extract the iron. Listen. Now, what are the raw materials? What do you mean by raw materials? The things you needed to produce something, we call it as what? Raw materials. So what are you going to make by using the blast furnace? You are going to obtain iron by using the blast furnace. So what are the three raw materials is? The raw material number one is, you are going to use coke. Coke means what? Coke means, we call in another term as carbon. We call it as carbon. Number two, we call it as hematite. We call it as what? Hematite. So that is going to be, what is the equation? Fe2O3. And then third one, we are going to use what? Limestone. The reason for all of these you will be learning. There are reasons why are we using carbon. There's a reason why are we using limestone. I'll tell you why is that. So that is calcium carbonate. Right. Now, from the bottom of the blast furnace, you have some space like this, like the two, like a tube. You send hot air. You send hot air through this blast furnace in order to heat it, right? Calcium carbonate means limestone. Okay, so what are the gases present in the air? You have nitrogen gas, you have oxygen gas, and so on you have. Now, can I use nitrogen gas to do this kind of work? Is nitrogen gas is reactive according to you? It is not reactive. It is an inert gas. So nitrogen gas is an inert gas. That means who is the highly reactive gas? That is oxygen. So what are we sending? We are sending hot air using oxygen. That means hot oxygen gases are being sent through the blast furnace in order to produce what? Extract iron. Clear? Yeah, we send from below. Clear? Got it? Okay. Now listen. Now we are sending hot air from below. Now my question is, which part of the blast furnace will be very hot? Top or bottom? Top or bottom? Very good. The bottom will be very, very, very hot. So because you are sending heat from the bottom, so when it goes up, what will happen to the temperature? Now say, from here if I send heat, when it goes up and up, what will happen to the temperature? Temperature will keep on increasing or will it decrease? Here now it is hot. When the air is going up, will it be increasing the temperature or decreasing the temperature? The temperature, it will reduce. Now let's see what is happening in blast furnace, and you have to make sure you have to remember this pattern of reaction. let's see what is happening in blast furnace, and you have to make sure to remember the pattern of reaction. Are you okay with that? So we have to remember this. Every year you get a question from that. Right, listen. Now, first of all, you will be adding coke. What are you doing? I will erase this because we have to learn the reaction. No? We will be adding the coke. Okay, so first of all, I will be adding carbon to the blast furnace. Now already you know that I am sending oxygen from the bottom. That means carbon will go and react with whom? Carbon will go and react with whom? That is the first step. Carbon will react with oxygen and form what? Carbon will react with oxygen and form what? Very good. It will form carbon dioxide. It will form what? Carbon dioxide. The instrument is blast furnace. Okay. So, carbon reacting with oxygen, it will form carbon dioxide. You know how to do the chemical formula for this one, no? Valency is +4. Valency for this one is -2. This and this cancel out. 2 times 4. 2 times 2 is 4 here. So you will exchange and form what? Carbon dioxide. So first itself we are adding what? Coke. First of all, we will be adding coke. Now the second step is this carbon dioxide. The carbon dioxide who formed right now inside the blast furnace will go and again react with the carbon. It will go and again react with the carbon to form carbon monoxide. It will form what? Carbon monoxide. Now can someone tell me what is the second raw material are we going to use? It's a method. It's the reaction that is happening inside the blast furnace. Initially you put the carbon. No, it's all the carbon is reacting quickly. Think like that. Is all the carbon is reacting at once? No. Little by little, no, carbon will react. That means a little amount of carbon will react with oxygen, become carbon dioxide. The rest of the carbon again will react with carbon dioxide to form carbon monoxide. Isn't it? That's how it will happen, no? So what is the second raw material? The second raw material is what will happen? You are adding hematite. So what is happening? When you eat hematite, now what is the gas that is now what is there? What is the remaining substance that is present here? The remaining substance will again react with hematite, again carbon monoxide. It will react with carbon monoxide. So carbon monoxide and hematite will be reacting. Clear with that? Until here, did you understand? Clear with that? It's like one part by one, they are coming, and they're reacting. That is how it is happening, okay? So now what is happening is, hematite, it will form, now what will happen? Hematite, what they will do is, they will react with carbon monoxide. Yes, what's the doubt? How did it become carbon monoxide? I told you, no, there are some situations we can't form the formula. If a carbon dioxide reacts with the carbon, however, they will form carbon monoxide. That is the nature. Okay? That is the nature. Now listen. So now what is happening is, carbon dioxide reacting with carbon, it form carbon dioxide reacting with the carbon, it form carbon monoxide. Carbon monoxide is reacting with the second raw material that we call it as hematite. Okay, hematite. Now what is happening? Now what is happening over here is, you need to understand that what is happening over here? Hematite, that means it will form. Now what you need to understand, in this situation only iron will be formed. Iron will be, other form of oxide of carbon will be formed. Now this is the main equation. Can you put a star over here? So what will happen is, so let me write here, when a carbon monoxide is reacting with hematite, what is happening, you know? It will turn into what? It will turn into iron. It will turn into iron plus carbon dioxide. You have to by heart. Memorize. You have to memorize this. How do I write? If a carbon monoxide reacts with the hematite, you will produce iron. After you produce iron, yes, but initially it will be liquid only. So carbon monoxide reacts with hematite and it will form what? Iron plus carbon dioxide. So you should know the balanced equation here. You should know the balanced equation here. So what is the balanced equation or before that? Before the balanced equation, initially what is the charge here? It will be in the form of liquid at the beginning. Then only it will turn into solid. Okay. What is the valency of the iron? What is the valency of the iron initially? +3, right? The valency of iron is +3. Now once it becomes iron, now initially when it was hematite, it was +3. Now once the carbon monoxide and hematite react together, now iron is produced. Now once the iron is produced, it is an atom. No? It is an atom. So there is no charge. What has happened to the charge? Charge has increased or decreased. Initially it was +3. There is no +3. Is the charge is increased or decreased? Decreased. So if the charge is decreased, we call these as reduction method. Reduction method. So they can ask you, which method is used to produce the iron? We say what? Reduction method. Clear with that? Clear with that? Got the idea? Got the idea? We call this as reduction method. Now we have to write the balanced equation. This balanced equation, you better memorize it because it will take a lot of time. So you know how to balance it, no? So we know to balance this. So we know this will come as 3. And here you will get here in front of that a 2. And then you will get a 3 here. You know how to balance it. So we don't want to waste our time by balancing it. Right. Okay. Clear the? Until here. Is it clear? Until here. Is it clear? Yes or no? Right. Okay. Now what you need to understand is, now what is reduction? What is reduction method? Reducing. So what is the type of reaction? They can ask you. What is the type of reaction that is used to produce iron? Every time in your MCQ, there will be a question. How are these elements are produced under the reduction? They can ask you which element is produced under the reaction of reduction. Answer should be iron. Okay. Right. Now what is the third raw material? What is the third raw material? What is the third raw material? Fourth one. The third raw material is calcium carbonate. Calcium carbonate is the third raw material. So why do you add limestone? You have already produced iron. Already you have produced iron. So why do you want this calcium carbonate? They can ask you an exam. Why does the calcium carbonate? The reason because calcium carbonate is here to remove the impurities. Talking, my tongue is also sleeping. So now what is happening is, so why do you have this calcium carbonate? Why do you add this calcium carbonate? The reason is because of to remove the impurities from the iron. That means you have to get the fresh iron. To get the fresh iron, you have to remove the impurities. Initially, it was in the ore. It was dirt. Now to remove all the impurities, we are using the calcium carbonate. Clear? Now say for example, when you take a rock, will it consist 100% of hematite? Will it consist 100% of hematite or will it have also contain impurities? It also has some impurities, no? So same like that, when you have the iron, to extract the iron, you have to remove the impurities. To remove the impurities, you are taking calcium carbonate. So you have calcium carbonate and heat it in a very high temperature. Now we heat the calcium carbonate at a temperature of 900 degrees Celsius. So it will undergo what? Calcium carbonate will undergo decomposition reaction. Calcium carbonate will undergo what? Decomposition reaction. Can everyone remember the decomposition reaction of calcium carbonate? Calcium carbonate, if it undergoes decomposition reaction, it will form calcium oxide plus carbon dioxide. Clear? This is by hearting. Things that you have to memorize. Step. Memorizing the step. You need this. So you need to memorize this. Important to memorize the calcium carbonate. How it is reduction. Initially you had +3, no? When it was a ore, it was +3. But after it was removed as a iron alone, did you have any +3 here? Did you have any valency as a +3 here? Initially it was +3, but now it is not +3. It will be +2. Initially it will be +2. That is what you have to remember. So initially it is +3 and it has become reduced. So because it has reduced it as a +3, that means there is no +3 anymore. That's the reason we call it as reduction reaction. Yes, right. Now what is the next thing is calcium oxide. Now calcium oxide will go and react with. Now what is the fourth one? You have two impurities. One is the sand, other one is aluminium impurities. How many impurities do we have in this iron extraction? You have two impurities. One you have sand, other one you have what? Aluminium. One is sand, other one is aluminium. So that means silicon oxide. The sand we call it as the silicon oxide. Now what is happening? Calcium oxide will go and react with silicon dioxide. It will go and react with one silicon dioxide. Now very easy equation. Can you say me? How many how many calcium do we have? How many calcium do we have? This equation is easy. One calcium, no. Put that one calcium. How many silicon do we have? One silicon. How many oxygen do we have together? This oxygen and this oxygen together. This and this together. 3. This is the outcome. Okay, now? So this one we call it as calcium silicate. We call this as what? Calcium silicate. So calcium silicate, we call this as calcium silicate, right? What is the next impurities I told you? Aluminium oxide is the next impurity. That is the 6th step. So what is the 6th step? Calcium oxide will react with aluminium oxide. So you know aluminium oxide, no? Now tell me how many calcium do we have? We have one calcium. And how many aluminium do we have? We have 2 aluminium. How many oxygen do we have? We have 4 oxygen. So we call this as calcium aluminate. Clear that? So that's it. These are the reactions you have to remember. Clear that? So these two, calcium silicate and calcium aluminate are the impurities that will be under the slag. You know slag, no? Slag means, can you look into that picture? Blast furnace picture. So when you look at the blast furnace picture, under that you can see there are 2 lines like this, mentioning that as a slag like this. Under the slag only, these 2 calcium aluminate and calcium silicate will be there. Got the idea? Shall we do this again? I mean, like for one more last time, you are going to answer this with me. Yeah. And try to write it with me, okay? Close your textbook for now. And you are going to write it with me. Now, we have to do the extraction of iron. When you do the extraction of iron, to do this extraction of iron, what do we need? We need ore. That ore, we call it as what? Hematite. We call that as what? Hematite. Okay. So now when you take the hematite, what are you doing is, now this hematite will be having an equation. That means the chemical formula Fe2O3. So that means the valency of hematite is +3. And when you take the iron will have two types of charges. One is +2 and +3. So before they become iron, they will have the +3 only. So now you need 3 raw materials. Raw materials to produce the iron. Number 1, we call it as hematite. Other one, we call it as the coke. Coke, in another term, we call it as carbon. And then we need the limestone, which you call it as what? Calcium carbonate. So to do this extraction of iron, what do you need? You need the blast furnace. So blast furnace will be looking like this. So it will be looking like this. And also under that, you will have a slag. Slag means to collect all the impurities like this. So this is the place we call it as slag, to collect the impurities, and through this place only they used to supply the hot air, which is oxygen gas. Clear? So first of all, what are they doing is they will be adding the raw material coke, which is carbon. So first of all, they will be adding the raw material carbon. So carbon will be going inside the blast furnace, and initially oxygen also they are. So when the oxygen also entering with the carbon, what will happen? Carbon plus oxygen, they will be forming carbon dioxide. Okay. Second situation is the balanced carbon dioxide will be reacting with the balanced carbon and it will form carbon monoxide. Okay, so now what is happening is what is the second raw material? The second raw material, now carbon monoxide will come down. Carbon monoxide is there, right? How does carbon dioxide react with carbon? Nature. Carbon dioxide, if they react with carbon, they will be forming carbon monoxide. Nature. We can't tell how. That is the truth. Okay, now listen. So now what is happening is carbon monoxide is there now. This carbon monoxide, they will be reacting with the second raw material, that is hematite. They will be reacting with the second raw material, that is hematite. So when carbon monoxide and hematite combine together, you will be completely extracting the iron, and then you will be producing what? You will be producing the carbon dioxide. Clear with that? Clear with that? Got the idea? Got the idea? Okay. Hope it is visible. Carbon dioxide. Now what is happening is, next step is, now you have produced iron. You have produced iron. So the fourth step is, now if you have produced the iron, you have to clean this iron. You have to clean this iron. Because you have to clean this iron, what are you doing is, you are letting the limestone to come inside the blast furnace. So once the limestone has come inside the blast furnace, due to the high heat temperature for about 900 degrees Celsius, high heat, calcium carbonate will undergo decomposition reaction to produce calcium oxide plus carbon dioxide. Clear? So this calcium oxide is done. This calcium oxide, what they will do, this is the person who will be removing impurities. So what are the impurities you have? One is sand, we can say silicon. Other one is aluminium. So the fifth equation will be calcium oxide will react with silicon dioxide. Because why do we say all this time dioxide, oxide? Because there is presence of oxygen. So what is happening? Simply, easily you can say calcium, how many are there? One calcium. How many silicon is there? One silicon. How many oxygen together? 3. So we call this as calcium silicate. We call this as what? Calcium silicate. The sixth equation is calcium oxide plus aluminium oxide combined together, you will be forming, how many calcium are there? 1. How many aluminium is there? 2. How many oxygen together? You have 4 oxygen together. So we call this as calcium aluminate. So what you need to understand is calcium silicate and calcium aluminate are called as the new name called slag. We call them as what? Slag. Calcium aluminate and calcium silicate, calcium silicate and calcium aluminate, we call them as slag. So this slag and the iron will form 2 layers. Iron and the silicate will, iron is there, this iron and this slag will form 2 layers. Like if you imagine, when you take oil and water, who will be floating? Who will be floating? Who will be floating? Water and oil. Who will be floating? Oil will be floating on top while the water will be at the bottom, because oil has less density than the water. Okay, now same like that, because of the density issue, what you need to understand is, same like that, the density of the slag is less than the iron. Who is the slag, dear? Calcium silicate and calcium aluminate are considered as the slag. So slag has the less density. So the person who has less density will come where? It will come at the top. The person who is at the bottom will be iron, who has the higher density. Clear? Clear? So from below of the blast furnace, I can easily remove and take the iron. Did you understand? Did you understand? The waste material released during the process of extraction of iron mostly is what? Carbon dioxide. Clear with that? Clear with that? Got the idea? Right. Okay. Huh. Clear now? So extraction of iron is done. These steps you have to remember. Can you do it by yourself quickly? Without looking at the textbook or my board? Give a try and see. Yeah. They will ask you to write those equations. That is very important. Calcium oxide. I'll try to do the tunes. We'll see, inshallah. I'm too tired because from morning I'm doing classes. Does the carbon dioxide become end product too? It can be considered as end product, or else we can say it's a waste material that is produced during the extraction of iron. Calcium oxide combined with calcium silicate, calcium one time, silicon one time, oxygen 3, so that's the reason we say calcium silicate, 3 times the oxygen. The same thing will happen when it comes to calcium aluminium. Silicon and aluminium are called as the impurities that is present in the iron. So both of them together only we call them as slag. The slag will be on top because they have the less density. And this one, this can harm the environment. Yes, the reason because you are you are releasing excess amount of carbon dioxide to the environment. So because of that, that can even harm the environment. Clear, right? Clear, right? Right. Now, when you go down the activity series, now let me talk about it. Now let's take down the activity series. When you take down the activity series, the elements are less reactive, right? So you can find, now say for example, you have copper, then you have copper, you have mercury, you have iron, sorry, not iron, silver, you have platinum, you have gold. So these copper, this mercury, this silver, platinum, gold, these people are native elements. So these people might be mixed with some impurity. So you can extract these elements by using what? Physical methods like winnowing, or due to density problems, you can do it and you can take it. Clear with that? Got the idea? The only person who does the extraction is what? What extraction? Reduction method done for the iron. Clear, no? Got the idea, no? Right. This one is mostly asked in your exams. So this is done by physical method. Let me write the activity series. So our activity series is potassium, sodium. I have to tell that song, then only I'll remember. Wait. Yeah. So I have to tell it silently. Anyways, right. From copper to the gold, you have to do the physical method in order to extract them. This will come to your MCQ. So copper, mercury, silver, platinum, gold, you are using physical method to extract them. Okay. From potassium to the aluminium, you will be doing electrolysis method to extract them. Electrolysis method. You will be learning that in electrochemistry. Then next one is from iron to lead. From iron to lead, you will be using reduction method, which will be zero charge. Okay. So zinc can be extracted by electrolysis. It can be extracted by electrolysis, or it can be extracted by reduction method. And hydrogen can be extracted by electrolysis method or other way of extraction. Clear? Got it? Understood? Got the idea? Your book also finished. Right. Now shall we go to the gases now? Some important parts in gases because we got only just 40 minutes left. We'll do some gases. Now just let me know. Did you feel bored when you were doing chemistry or did you feel like, oh yeah, interesting? These things I didn't know, but this seems to be good. Right. Okay, let's move on. You are sleepy because you are very tired. Okay, right. Listen. Now let's talk about gases. So when you talk about gases, you find now when you talk about gases, will you find nitrogen, oxygen, hydrogen, carbon dioxide in the air? Yes. So when you say we'll put a chart and we'll study. Now mainly what are the gases you are going to study mainly is you are going to study about hydrogen gas, oxygen gas, and you are going to study about carbon dioxide gas. So when you talk about gases, let's talk about the physical properties of the gases. Now think about the physical property of gases. Do they have color? No. So they are colorless. So gases are going to be colorless. Do they have a smell? No. They are odorless. So they do not have smell as well. Hydrogen. Are they soluble in water? Okay, so what are the, yes, now think about hydrogen. Hydrogen is soluble in water. It is slightly soluble in water. Not everything. Listen, hydrogen is slightly soluble in water. Oxygen, nothing. This fish will breathe using oxygen. No, they need to, aquatic organism needs oxygen to breathe. Is oxygen is dissolving much in the water? Yes. So oxygen, we say they are soluble. Carbon dioxide. Carbon dioxide is not soluble. They are not much soluble. Right? Now listen. Now what is the relative molecular mass of this hydrogen? The relative molecular mass is 2. Oxygen, what is the relative molecular mass of oxygen? That is going to be 32. The relative molecular mass of the carbon dioxide is 30. Sorry, not 30. It should be 44. Now tell me, who has the higher density? Who has the higher density? Yeah, it will be releasing carbon dioxide. That's what it comes out. It is not soluble. That's the reason it comes. Very good. So carbon dioxide has the higher density. Who has the least density? Hydrogen has the least density. Clear with that? Clear with that? Oxygen is denser than air. Carbon dioxide also denser than air. So when you take air, it may contain hydrogen. It may contain oxygen. It may contain carbon dioxide. So already we know that they do not mix with water and some will mix with water. So already we know about it. Right. Now when we talk about this density, now you have a balloon filled with hydrogen gas, you have another balloon filled with oxygen gas, and another one is filled with carbon dioxide gas. Think about this situation and tell me which balloon will fly. Which balloon will fly? The balloon which is filled with hydrogen or oxygen or carbon dioxide. Very good. The balloon that is filled with hydrogen gas will fly. Now, usually we use our mouth and we used to blow the balloon and we fill the air. No. What is that gas that are we filling? What is the gas that are we filling? Very good. Carbon dioxide. I thought you would say oxygen. Very good. Right. Now, let's talk about the chemical properties of the hydrogen, oxygen, and carbon dioxide gases. Now, guys, tell me what is combustion? Already I told you. Burning something in the presence of oxygen, we call that as what? Combustion. So because of that, you say oxygen is a supporter of combustion, isn't it? Without oxygen, can combustion take place? No. Have you done with this experiment where you put a candle on water and you cover it with the gas? What will happen to the flame after some time? It will go off, no? So the flame has used oxygen present in the water and the water level will try to rise up. So that means it has used up the oxygen which is already present in water. Then the flame will goes off. Have you done this experiment when you were small? Yes or no? Yes or no? You may have done. I think so. You should have done this. Right. Now let's say you have a piece of wood. Okay. Now say you have a piece of wood and you have a piece of gold. Now if I burn both of these substance, which will burn and which will not burn? Wood will burn or not? Wood will try to burn, gold will not burn. The combustible substance means the substance that you can burn, we call it as combustible substance. So when you burn wood, it is going to react with oxygen. Now gold is not burning. No. Will the gold react with oxygen? No. Gold is non-combustible substance, so it will not react with oxygen. So think about hydrogen gas. We say hydrogen gas is a combustible gas. That means we can burn the hydrogen gas. So if you can burn the hydrogen gas means this hydrogen will react with whom? It will react with whom? This hydrogen gas will react with whom? It will react with oxygen. It will react with oxygen. So have you heard about fire extinguishers? Fire extinguishers in your school we have behind the door and everything for emergency purpose and all. What do? To put off the fire, we use the carbon dioxide. The process of combustion stopping. That is, we call it as what? The extinguishing, no? So what is happening is, you need to understand. So in fire extinguishers, they have put carbon dioxide and you have to spray. So when you spray the carbon dioxide, the fire that is taken place will be stopped. So that means when we talk about more oxygen, oxygen helps the fire to burn. Now fire to take place. But when you talk about carbon dioxide will it allow the fire to burn more? Will it allow the fire to increase? No, it will decrease. So that means you need to understand, if the oxygen is a supporter of combustion, means carbon dioxide is a non-supporter of combustion. Clear with that? Clear with that? Understood that? Now in industries, where do we use hydrogen gas? Where do we use hydrogen gas in industries? We use to production of margarine. To produce margarine, we use hydrogen gas. Then rocket fuel, as a rocket fuel, we use the hydrogen gas. Carbon dioxide, to produce dry ice, we use carbon dioxide. Oxygen, we know very well, it helps in respiration. We do so many things out of one oxygen. Packaging also done by the carbon dioxide. Clear? Got the idea? Got the idea? Yes or no? Okay, right. Listen. Now let's talk about how can you prepare these gases in the lab. Let's talk about how can you. We will be by 12 we will be stopped. Okay. Carbon dioxide used for producing dry ice. It is also produced for packaging. So for those things. Okay, right. Now let's talk about how can you prepare these gases in the lab. Now you have studied about preparation of hydrogen gas. No? So now let's talk about the activity series. Now guys, tell me, hydrogen can be produced by using what method? We have already studied. No, what did I teach you? That hydrogen gas can be produced using what method? What is that method of producing? Production method. Now I told you iron can be produced using the reduction method. Then hydrogen should be what? Hydrogen is electrolysis. No, we use the electrolysis method to do the production of hydrogen gas. Now listen to me. Now the elements above hydrogen gas will react with dilute sulfuric acid to liberate hydrogen gas. What do we need to understand? In activity series, there are elements above the hydrogen. No, those elements will react with hydrochloric acid to produce hydrogen gas. That is the main way of producing hydrogen. Okay. So to prepare the hydrogen gas, I can either use magnesium or I can use zinc. So they will not take sodium, they will not take calcium because they will catch fire. So in the lab, you can only use magnesium and zinc. Any element can be used to produce hydrogen. Now, any element they can react with. Any elements can react with hydrochloric acid to produce hydrogen. Now, we are doing in the lab now. So we have to be very careful. So in the lab, we most of the time we will use what is that? What is this? I forgot this element name. Magnesium. So magnesium or zinc. So you will be using magnesium or zinc most of the time in the laboratory. Okay. So tin, lead, most of the time it's very rare we use, but this is the most common. This is the most common elements we use in the lab. So now say for example, this magnesium is going to react with hydrochloric acid. Now see, you know very well magnesium will be replaced by the hydrogen. So therefore you will be producing what? Magnesium chloride and the hydrogen gas is produced, isn't it? Got the idea? So they can ask you, how can you produce oxygen gas in the lab? By what reaction? Now they can show you a reaction like this and they can ask you, what is the gas that is produced in this particular reaction? That is hydrogen. So whenever you see a metal, if a metal is reacting with, we don't want to balance it right now. So already you know balancing, no? So right. So when you talk about metal, if any metal is reacting with the acid, remember they will be producing hydrogen gas. So if in case if they give you any equations to you or ask you to prove any equations that can produce hydrogen gas, think about a metal and acid, right? Let's talk about how do you prepare oxygen. Usually to produce oxygen, what is the difference between hydrochloric acid, dilute, and hydrochloric acid? Dilute means it is mixed up with the water, that is less powerful. That concentrated means dilute. So dilute means it is not concentrated, it is mixed with water. Hydrochloric acid, concentrated hydrochloric acid means that is the original one. It is very powerful, we usually don't use in the lab. Okay, right. What is that? What is the next one? Aqueous. I will see what is that, because you sometimes say me some new words. Okay, right, look here. So how can you produce oxygen gas in the lab? Is by doing the decomposition reaction. So what is the most common decomposition reaction to produce oxygen gas? Usually we use hydrogen peroxide reaction. This one you have to by heart. Hydrogen peroxide reaction will help us to produce what? It will be helping us to produce the oxygen in the lung, right? Next one, potassium permanganate. So potassium permanganate will help us to produce what? Oxygen. Then again, manganese dioxide will be there. Potassium manganate, this one, manganese dioxide. Plus you will be forming oxygen. So these are the two decomposition reactions that will help us to produce what? Gases. Clear with that? Understood that? Got the idea? Got the idea? Then you can ask me, how is the carbon dioxide is produced? So carbon dioxide is produced in what reaction? So carbon dioxide is produced whenever any carbonate is reacting with, if any carbonate is reacting with dilute acid, then you will be forming carbon dioxide. Example, calcium carbonate is reacting with hydrochloric acid, they will be forming calcium chloride plus carbon dioxide plus water. These reactions you should know. Clear with that? Understood that? Got the idea? Got the idea? Clear? Right. So almost we have done with that part. Almost we have done with that part. Clear, right?
So we are done with the lesson also. So the only thing that you have to learn is about how you can collect these gases and how you can move on with that. Right. Clear, right? Any doubts in this part? So you learned a lot of things here and you got so much of things to get into that, and then you are here right now. I hope everything is clear. Whatever I told you is clear, right? Right, so let's wind up because I'm like, from morning I had classes, too tired, almost 12 hours of classes. Right. So I will try to have the electrochemistry session by next week. Okay, I will try to post it on my channel. So if any of your friends who wants to learn that lesson, you can ask them to join. I will be sharing the post regarding that, inshallah. So let's see. So see you on the next class and have a good day. Take care. Whatever it is, I will be updating in the channel. Right. So have a good day. Take care and see you guys. Not tomorrow, Seema. So have a good day, take care, good night, and I hope you had been a good student right now because almost time you all had been working hard, you all have given dedication, and everything is worth it. Keep working, you're gonna rock. Don't worry, everything is going to be easy, and I'm here to help you anytime. Take care, good night. Bye. Yeah, that is day after tomorrow, no? Health recap. Tulosh, thanks a lot.